Hey, what's up guys? Welcome to Module 8 of the CompTIA A course. Now today's module is titled Network Infrastructure Concepts. As you might have guessed already, it's all about network infrastructure. Speaking of which, the main topics on today's module, here they are on the right hand side. Wired networks, so that's network cables, coaxial cables, that kind of thing. It's not just limited to that. Network hardware devices like a network card, obviously also not just limited to that. Wireless networks, the different kinds of frequencies you get, there's many that you guys need to know about. Internet connection types, network configuration wizard, and lastly, network services. So now that we've got that out of the way, guys, please give the video a like. It does help this video, it does help my channel, and quite frankly, like I've usually said before, it's basically my payment for doing these videos for free. If you're new to the channel, oh goody, please subscribe down below. Otherwise, you're not going to know when the next video comes out. What's the point of watching just one video and not knowing when the next one comes out? It's a whole course, after all. It's 18 modules. Otherwise, you're not going to know when the next one comes out. If you guys do need additional support, besides watching just these videos of mine, you're welcome to drop a comment down below. I'll gladly get back to your question. And if you need even more support, you're welcome to join me on Discord. There's a server link in the description down below, right next to the timestamps of these videos. Be sure to use those timestamps. So that Discord is not my server. It's got about 2,200, 2,300 people in it. Some of them are experts. Some of them are new in IT. They're learning, maybe like you. And if I can, assist you, someone in that community will definitely assist you. If you're looking for me, you can either have a one-on-one chat with me in that Discord server. I'm listed as Burning Eyes Tech, or someone else in the community will assist you. Someone will definitely assist you in that community. I can assure you that. I mean, it's over 2,000 people in that community. Besides the link in the description, like I mentioned, there's also timestamps. So make sure you use those timestamps if you're looking for a specific topic, maybe. If you're just revising on a certain topic or you want to know about something specific, feel free to make use of the timestamps down below. It's going to make your life a lot easier. These videos are quite long. I mean, it's a whole module after all. So use the timestamps down below if you're looking for something specific. So guys, now that we've got all of this out of the way, I think let's move on to our first topic in this module.
Okay, so first up is network types. So as you guys can see, in its most simple form, a network consists of two or more computers connected to each other by an appropriate transmission medium which allows them to share data. This transmission medium can be anything. It's maybe a cable, like a network cable. It could be some sort of wireless frequency. Maybe you guys are within the same household or the same office building, and you're connected by maybe the Wi-Fi, in other words a hotspot of some kind. That is a network in its simplest form. The reason why we are on the same network, normally of desktops and laptops and that kind of thing, is to generally share information, data. It could possibly be just to play games against one another or with one another, but usually in the old days it was to share data with one another and so that we can collaborate with one another. Now, if we look at some of the bullet points we've got here at the bottom, purpose provides services and resources to users. Resources in the sense of I can go and connect to my fellow colleagues, I can get information from them, they can get information from me. I can also go and connect to servers in my organization. These servers could be on premises. In the old days, 5 to 10 years ago, they were all on premises. Nowadays, these resources actually might very well be in the cloud. In other words, they're hosted somewhere else on someone else's property, and it's being rendered back to me or my company for a monthly subscription service. So more on that later in the course. Now, historically, files, folders, printers, and email databases is something we would normally use this for. Nowadays, like we said, it's not the only thing. If you look there, it says modern web applications, social networking, VoIP. So in other words, that's calls over the internet. If you were to go and make a Skype call, Zoom call, Microsoft Teams call, whatever kind of call over the internet, that generally is a VoIP call. Voice over IP. You're not using the old conventional telephone lines, POTS lines, POTS, plain old telephone system. You're using an Ethernet cable, a LAN cable, or network cable, as some of you guys might know it. And then obviously multimedia conferencing is something we might use it for. Now, with regards to the types of networks we get, I see they've given us LANs, WANs, and MANs. That's actually not the only ones we get. You also get GANs and the list goes on, but those are the three main ones you guys need to know with regards to your exam. LANs is probably the most common one you get. That stands for Local Area Network. It's one of the smallest networks you get. I wouldn't say it's the smallest one. One of the smaller ones you get is actually a PAN, PAN, which stands for Personal Area Network. The smallest one, being Personal Area Network, is normally you and your machine. So if you've got a laptop, for example, and you've got a printer plugged into it, or a scanner, or your phone's connected to it, that small little space where it's just you, your machine, and your hardware that's plugged into it, that is your PAN, your Personal Area Network. So your phone could be connected to your laptop wirelessly or via cable. That's a PAN, boys and girls. My printer can be connected to my laptop or my desktop. That little network between me and my printer, or my device and my printer, whether it's wireless or cable, is a PAN. Local area network, which is still one of the smaller ones, is generally confined within a building. It's within your household building, or it's within your office building. Now, granted, some office buildings are obviously quite large in size. It might very well be hundreds, if not thousands of people in there. That is still a LAN. So generally a LAN is only a few people. It could be 2 people, could be 20 people, but it could very well go up to a few hundred, maybe even a few thousand people. So LANs could theoretically go actually quite large in size. You never know. So the point here is, as long as you remember, a LAN is generally within the same building. And if you connect within the same building, doesn't matter if it's via cable or via the Wi-Fi, in other words, the wireless frequencies or the hotspots, that is still part of the LAN. It doesn't matter if it's wireless or cable, as long as you're within the same network, within the same building, it's generally seen as a LAN. Now, MAN should actually be there in the middle. WAN is actually the one at the top. I'm going to give you guys a picture in a second. MAN stands for Metropolitan Area Network. So this is generally more than one building now. So you might have 2 buildings, 3 buildings, 4 buildings. These might all be, belong to your office. And within each of those 4 buildings, you've got a LAN. And these 4 buildings are generally within the same city or the same town. They might be on opposite sides of the town. One could be on the north side, one could be on the south, one on the north, and one on the west side. And they're linked to one another via some means. Usually it's via some form of long-range wireless frequency. It's not limited to that, obviously. So these are basically just LAN networks that's connected to one another. It's usually your own office buildings that's connected to one another within the same city. So that's the base description I can give for that one. We'll give you a picture in a moment. And then WANs. That stands for Wide Area Network. Slightly bigger than a MAN. And where we were previously limited to within the same city for the most part, now, yeah, it's not just one city. It might actually be multiple cities connected to one another. So if you've got a huge company, or it might be a division of the government, maybe it's branches of the government, it's a certain department of your country's government, that department, maybe it's the traffic department of your government, their buildings in various cities are connected to one another. And this maybe might be done via a WAN of some kind. So that WAN is stretching, between multiple cities, but it's not necessarily going to leave the boundaries of your country. Now, as for the picture I was promising you guys, here's a nice little picture. If you look at the bottom, there we've got a bunch of buildings. So a LAN is generally going to stay within the building. Might be a small building, might be a big building, but it's within the building. MAN is normally between various buildings, but generally within the same city or town. WAN is when I want to go and connect those different towns to one another. So LAN, one building. MAN is multiple buildings, so you can basically say a MAN is connecting multiple LANs to one another. A WAN, one might say, is connecting multiple MANs to one another. So it's even bigger than the MAN one, if you might say it like that. Okay, let's take a bit of a look at Ethernet types and standards. Now, for those of you that don't know yet, Ethernet is usually a network cable. Well, at least one of the many kinds you get, probably the most common kind you get. So if you go into the average household, maybe the average office, the kind of network cable you'll find that you're going to go and plug into your laptop or your desktop, router, switch, That's generally an Ethernet cable. They come in various speeds, but at first glance, visually they look the same. Meanwhile, internally, they're not all the same. They come in various speeds. I think that's the most important part here. The color of the cable absolutely does not matter. Generally, the most common color I've seen is normally like a white, maybe grayish kind of color. But technically, they can actually come in any color. I've seen them in red, blue, yellow, black. Any color you can pretty much imagine, I've seen them in. The color of the cable does not matter. What does matter is the speed of the cable, and this you can sometimes establish by looking at the cable itself. If you look at the cable very closely, normally in very small text on that cable somewhere, it's printed from the factory, and you can actually see what kind of cable it is. Something we'll get to in just a few seconds. So most cabled LANs build on Ethernet. So cabled means it's a local area network, but it's not wireless. It's specifically made via cable. So it's probably going to be via network cable. At least at the time of this course, it was still Ethernet cable. Now some of the types of cables you get is 10, so 10 Mbps, 10 megabytes. That's not something you guys are going to encounter, so I wouldn't worry about that. I would say ignore the first one completely. Second one is fast Ethernet, 100 base. So that is a normal Cat5. Cat, C-A-T, Cat stands for category. That is a terminology you guys are going to hear about a lot in IT. It is something you're going to hear and see a lot in A+, in the exam, and pretty much anywhere, I would say, if you're going to be in IT. So get used to the term Cat, Cat5, Cat6, that kind of terminology. It simply just means what kind of category cable you're working with when it comes to network cable. More specifically, Ethernet network cable. So Cat5 normally runs at 100 base, 100 megabytes. When you get gigabit cable, which is normally 1000 base, so that runs at about 1 gigabit per second. It's about 10 times faster than the previous one. And then the last one there, which is not everywhere yet, you get some companies that will have it inside. That is 10 gigabits per second. That's insanely fast. It's even 10 times faster than the previous one. So about I would say 10 years ago, the average company would run 100 megabits. And then they started phasing out those cables and those network switches of gigabit switches and cables. We call them gigabit switches and gigabit cables, which is obviously 10 times faster. And now we're setting up a situation where we're going to do the exact same thing again and just go 10 times faster again. So maybe in another 5 or 10 years, we'll probably go 10 times faster again. Maybe it'll be 100 gigabits. You never know. Anything is possible. Something else you guys may or may not see later during the course and just generally in life is the IEEE 802.11. Now the IEEE 802 is something you're going to see a lot, and then normally after dot you're going to see 802 dot. It specifies what kind of network it is. So generally, as a rule of thumb, when you see dot 11, I want you guys to think wireless. Dot 11 normally means it's some form of wireless network. So normally behind the 11, you'll find some sort of letter. Something we'll still get into. I'm not sure if it's going to be in this module. It might be in a later module in this course. But behind the 11, you'll see a letter. It's going to be like 11A, 11B, 11G, 11N, 11AC. Those are all wireless frequencies I just mentioned to you guys. So those are used for wireless LANs. That's what the WLAN stands for. It's wireless LAN. It's still a LAN. It's just a wireless LAN. There's just no cables involved. All right. Now, as for the cables that we use in these networks, in other words, Ethernet cables, some people might call them LAN cables. Some people might call them network cables. Now, if you were to go and open one of those cables, what you would find is 8 wires. Normally, you're going to find orange and orange-white, blue and blue-white, brown, and then brown and brown-white, and then green, and then green and green-white. So when I say green and green-white, I mean the cable is actually white and green. It's a mix. One is just green, one is green and white, one is just brown completely, one is brown and brown-white. You get the idea. So what you'll also generally see, I would not say this is set in stone. It depends on where you buy the cable and how much you paid for it and what kind of quality it is. Those cables would generally be twisted around one another, those 8 wires. Your orange and orange-white will be twisted around one another. There's a reason for that. Blue and blue-white brown and brown white, green and green white. They're twisted around one another. That's what you want to see. So if you open a cable and you find the 8 wires, but they're just straight, they're not actually twisted around one another, that's bad. It's a very poor quality cable. So if you paid normal price for it, you've probably been ripped off. Or if you paid a very cheap price for it, well, now you know why. So you do not want to buy a cable where the cables are not twisted around one another. So they twisted around one another, from the factory because it prevents certain things. If you look at point 4 there, it says twisted to reduce crosstalk and EMI. Crosstalk is a technical term we use, for interference. So these cables, they're very, the voltage and stuff can't actually kill you anything, but they do emit a very, very small little magnetic field and things like that. And with them being 8 wires in that small little space, so close to one another, if they emit that off, one another, they actually interfere with one another, the signals. So one way they can kind of sort of, reduce that, not completely get rid of it, is to kind of twist the cables around one another. I don't know who's the guy who came up with that, but that guy deserves a six-pack if you think about it. It also prevents, to a certain extent, EMI, something we'll still get into later during the course. So EMI stands for electromagnetic interference. So any cable that's got a current running through it, some form of electricity, whether high or low, gives off EMI. The more the electricity, in other words, the higher the voltage, the higher the EMI. That's not the only place you'll find EMI. So if you, for example, have a power cable, a normal power cable in your house or your office, believe it or not, that cable actually gives off EMI. You as a human cannot see it, you cannot feel it, but it does interfere with certain things. If you've got a network cable right next to a power cable, especially if that's a power cable that's got a huge amount of volts running through it, that actually gives off EMI and it's going to interfere with your network cable. So generally, as a rule of thumb, in companies, when we go and physically, put the network cabling into your walls and the trunking and under the tables and under the floors and in the roof, we generally, as a rule of thumb, do not put network cables near power cables. So you'll find that they normally are separated from one another with good reason, because those power cables give off massive EMI, and if we're going to be running our network cables parallel to our power cables, that's going to cause interference, for those of you that don't know. So we're going to get into more detail on that later during this course, in a different module which actually focuses on that. But now you've got a taste as to what EMI actually is. Now, as to Ethernet cables in general, you get two kinds. You get UTP and you get STP. I want you guys to get familiar with those terms because that will definitely be in the exam. 100% guaranteed you are going to be expected to know what an Ethernet cable is. You're going to be expected to know the different kinds you get, in other words, UTP and STP. What is the difference between them and what is the pros and the cons between them? That is what you need to know for your exam. So this part is very important for your exam, the parts we're about to explain. You need to know what a fiber cable is. You need to know what a coaxial cable is and where and when you would want to go and use those various kinds of cables. The same is going to apply to wireless frequencies, but that's obviously later. Now UTP, in case you guys haven't seen it already, it stands for unshielded twisted pair. Now what is meant by the word shielded or unshielded is around those 8 wires we have. As you guys can see there in that little picture in the middle, it says there's an insulated jacket. That's just a normal little insulation, to prevent you from touching the wires and all that. Normal insulation. And then you've got obviously your 8 wires, there's 4 pairs of them twisted around one another. That's normal UTP. But if you go look at STP, shielded twisted pair, before you get that little insulated jacket, there's actually a little shield around them. So I suppose you can compare it to tinfoil, kitchen tinfoil that you would normally use for cooking and stuff. It's very much the same. It kind of feels a little bit thinner than that, but around the 8 wires, you'd first find your little, let's call it tinfoil, if you will, and then around the tinfoil, you'll find the old usual insulated jacket. That little tinfoil is basically like a little insulation that prevents, it shields it. That's why it's called shielded. It shields it from EMI. It's not 100% effective, but it's damn well very effective, So any environment where you're going to have a lot of interference, you would rather use a shielded, cable versus an unshielded. Now, if we look at our little points there, I just want to go through it again. So we know Ethernet cable is very widely used, especially UTP. UTP is the most widely used one, and it's probably because it's cheaper. It's cheaper versus shielded in most cases. 4 conductor pairs, so in other words, 8 wires or 4 pairs. Insulating sheath, that's just a normal insulating sheath. Twisted to reduce crosstalk and EMI, we know that much. Paired wires carry equal opposite signals. It's got the PVC jacket, that's the little insulated jacket we talk about, and it works well in low interference environments. So if you're going to be putting it in a normal wall away from power, or in a roof away from power cables, away from fluorescent lights actually gives off EMI, by the way, then you can go and use your normal conventional UTP. Now, it doesn't matter whether you use UTP or STP, they both have a limited range. If you go look at your manuals, if you happen to have a manual, the manual will tell you an Ethernet cable, doesn't matter what category it is, they generally are limited to 100 meters. So I work in the metric system, so I know it's 100 meters, and the exam is going to ask you in the metric system, it's going to ask you about meters. So metric system wise, going according to the exam, it's going to be 100 meters. I think in the opposite system, it's about 300 and something feet, 325 or something feet like that. We'll check in a moment. I've got it here somewhere. Anyway, so they're going to expect you to know what is the maximum distance you can go with a network cable. Doesn't matter if it's category 5, category 6, category 6A. What is the maximum distance it can go? And the answer to that is 100 meters. Now, that's the book knowledge. That's the theory answer. Realistically, in real life, that is not the case. The exam, however, is based on theory knowledge, not real life situations. In real life, I can assure you that cable will not go 100 meters. Realistically, in real life, you can only expect it to go maximum 90 meters. And that's assuming you've got a very good cable. It's got thick copper, it's maybe Cat 6, there's no interference, that kind of situation. But if you're using one maybe that's got thin copper in it, there's a lot of interference, that kinds of stuff, then you'll be lucky if you get 70 meters out of it, realistically speaking. So what you're going to have to do every 70 to 100 meters is going to have to put in a repeater. According to the course, you need to go and get a repeater, which is basically just going to go and rebroadcast the signal. It's some sort of device in the middle, which is an actual repeater. In real life, most of us don't actually use a repeater. We use another switch. So something we'll go into more depth on later on. So it's just more viable to just use another switch because there's probably going to be one. In the exam and in the course, they test you on repeater. In real life, however, we use another switch. So that's the difference between book knowledge and real life. Moving on to our CAT standards here, just to give you guys a list, since we were talking about those. I couldn't remember. I thought it was 325 meters. It seems it's 328 feet. I said meters, it's feet. So there we go. You get your Cat 5 way on the left, top, top one. That's Cat 5. Category 5 is what it stands for. The capacity is 100 megabits per second. Maximum distance, according to the theory, is 100 meters or 328 feet. Now, that's what you guys need to know for the exam. Memorize that 100 meters. You need to know that for exam. It will be a question exam. So you need to know that for your exam. As soon as you pass the exam, you can forget that number because realistically in real life, it's probably going to be less than that. Now, Cat 5e, if you look at it, physically in your hand, if you have them both in your hand, Cat 5 and Cat 5e, they're going to, look the same. They're going to feel the same in thickness. But in reality, the 5e one is actually 10 times faster. The only way you can really distinguish between them is by looking at the cable very, very closely for that printed text, which actually says 5e. So realistically, the chances of you finding Cat 5 is very unlikely unless grabbing some old cable out of a wall. But you can't actually get a hold of them anymore, at least based on my experience. So 5e is 10 times faster at 1 gigabit per second, same distance. Cat 6, same speed, same distance. However, the cable visually is slightly thicker. If you hold up a Cat 5 or Cat 5e, because they look the same, if you hold them up next to a Cat 6 cable, you'll notice the Cat 6 cable is slightly fatter in size. I want to actually say it's fatter. I want to use that word. It's slightly a little beefier. So if you need to go and crimp it, in other words, go put a connector on it, you're going to find slightly harder to do so because it's slightly thicker, Now, moving on to Cat 6, well, the second one I should say there, you'll notice one of them says 1 gigabit per second. The other Cat6 there says 10 gigabits per second. The only real difference between them is the speed and the distance. Now, the second one from the bottom, the one is also just called Cat6. I don't think that's the actual name. As far as I know, it's called Cat something else. I think it's Cat6b or Cat6, something like that. Realistically, I never see that one. I've never seen that one. I don't know anyone that's ever seen that cable. Maybe you guys can tell me otherwise. Maybe you've seen it. If you have, feel free to drop that in the comments down below and let me know if you've seen that cable. I would very much like to know if you've seen it and where and when you've seen it, because I can't imagine you would seeing it. You can see it's limited to, unfortunately, just a mere 50 meters. So why would I go and get myself a Cat6 cable, the one that's 10 gigabits per second, if I can go get myself a Cat6a cable, same speed, and it can go twice the distance? It's just so much better in quality. So that is why you will not find that one. I think it might have been a test run or something. You're not going to find it. You might find 5, if you go look at an old building or an old network. You might find 5E, depending on where you buy it. You might find 6, normal 6 that goes 1 gigabit per second, 100 meters. But you're not going to find the 6 one that goes 10 gigabits per second and 50 meters. I don't know where you're going to find that. I've never seen it. And then you get the last one, obviously 6A. So that one realistically is probably going to be the one where we're going to be moving to in a near foreseeable future. I think the average company at this point in time is on normal 6, Cat 6, being the 1 gigabits per second one. That's what the average company is on right now at this moment. And probably in the near foreseeable future, we're going to be going to Cat 6A. But it's not a matter of let's just yank out all the cables and put in new cables. You also need to quite often go and replace other network devices, like your network switches. They need to be able to handle that speed. If they can't handle it, it's not going to work. And then we have the other one I mentioned to you guys earlier, being STP, shielded twisted pair. So earlier we spoke of UTP being unshielded. Now we have shielded. I've accidentally, for the most part, already explained it. So if you want, you can just go back to that timestamp. Go use the timestamps in the description down below to make your life easier, like I said in the beginning. Now, as for shielded twisted pair, there's actually more than one thing in IT, in networking, that uses the abbreviation called STP. So STP, in this case, stands for shielded twisted pair. But there's actually something else, believe it or not, that also stands, that also uses the abbreviation STP. And that is spanning tree protocol. It's also actually something in networking we use normally to do with routers and switches and stuff. Not something you guys need to know at this point in time. It is not something covered in this course at all. It might be covered in Network Plus, which is the next course I'm going to be doing for you guys after A Plus. It might be covered there to a certain light extent. But other than that, it's not something you really cover. That's normally something we cover in Cisco and in Huawei. I know I cover that normally quite extensively in Cisco when I used to teach Cisco. So yeah, shielded twisted pair originally used braided shield to reduce interference and crosstalk. There you guys can see that little picture. There's the little tinfoil shield I was speaking of earlier. So we still have our 8 wires, still twisted around one another, except now before you get that little insulated coating, or that little sheath as they call it, we've got a little tinfoil around it. So you can see there's a little wiring around it as well. All of this helps prevent, the EMI they spoke of earlier and the crosstalk. Now this cable is ideal to be used in any environment where you've got a high amount of EMI. So if you know for a fact you have to have your network cable near power cables, there's no way around it, you're stuck with that situation, then you might want to go for STP. It's not going to completely get rid of that EMI, but it's going to drastically reduce that interference. If you're going to have to, for example, take a cable over in the roof, because most of these network cables tend to go in the walls and in the roofs of building, when it goes in the roof, if it's going to be going through near lights, more specifically fluorescent lights, and that actually is the most common light used in most corporate organizations, if it's going to be going near those lights or over those lights in the roof, that's bad. They don't give off a lot of EMI, but they do give off EMI. So if that cable is going to be passing along or very near enough of those lights, you're going to be having a problem. So you want to avoid that. If your network cable is, for example, going to be, going near heavy machinery, a motor of some kind, anything that draws a lot of amps, a very large amount of electricity, that heavy machinery generally gives off a huge amount of EMI. And in situations like that, you want to use anything but a UTP cable. You want to use STP. I suppose you could use fiber. Fiber
does not get influenced by EMI at all. It uses glass, not copper inside of it. But fiber is a topic for completely way later. We're not talking about fiber right now. Just thought I would mention that fiber does not get influenced by EMI at all. Coaxial cable, which is pretty much like the one you would find behind your old TV systems and your decoders and stuff like that. Those cables also have a form of shielding, not complete shielded like like fiber, but it does have shielding to a certain extent, kind of like your STP cable. So it's also pretty good at mitigating this whole EMI situation we're facing.
Alright guys, so now that we've talked about UTP and STP, regarding Ethernet cables, let's talk a bit about the actual connector side of things. Now, in case you guys don't know, that's the little plastic doohickey that you'll find on the edge of the cable. Each network cable, being an Ethernet cable, has two connectors in most cases. These little connectors, if you were to go and open them, obviously they've got 8 wires. I mean, like we've just discussed previously, there's 8 wires in each of these cables. Those 8 little wires are going to go into that little transparent connector. It's basically made out of plastic. And once you've got all the cables into that little plastic doohickey, you're effectively going to be doing what we call crimping. Now, crimping is a special tool we use, and we're going to go and slide a little cable with its little plastic connector into that little tool, and in a nutshell, it's going to basically just apply pressure to the little copper pins and allow them to cut into those wires. As soon as they cut into those wires, they automatically make contact. So all of that we're going to discuss in just a few moments. Now, with regards to these little connectors, we call them RJ45 connectors. Now, that is something you guys need to know for the exam. You might have heard me say it before. In the exam, you need to know your wireless off by heart. You need to know your cabling off by heart. The different kinds of cables you get, their speeds, their ranges, their pros, their cons, their connectors. Same applies to wireless, the different kinds of wireless frequencies you get. When do we use them? Why do we use them? Their speed, their range, their pros, their cons. All of that is something you guys need to know for your exam. Pretty much off by heart. I actually want to go so far as to say you need to know that off by heart. Now, as for the RJ45 connector, that connector is something we use for all Ethernet cables. It does not matter if you're using Cat5, Cat6, Cat6A, all of them use the same connector, the exact same connector. It's an RJ45 connector. So let me just scoot this picture up a little bit for you guys so I can show you what it looks like. There we go. So on the right hand side, there's a very, very enlarged version of the RJ45 connector. That one you can see is transparent, they normally are. And that one is obviously a brand new one which has not been utilized yet. It consists of 8 pins because you obviously have 8 wires. Your 8 wires are going to slide into that little connector. You're going to press down with your little RJ45 connector crimper, and that's going to press those little copper pins into those little 8 wires. Now on the inside of that connector, those little copper pins have got very sharp little blades, if you will, and they automatically cut into those wires precisely and make precise contact. Now these wires are color coded. We've already talked about, we know there's 8 wires. We know we get them in orange, orange white, green, green white, blue and blue white, brown and brown white. Now, did you know they actually need to go into that connector in a specific order? Now, the first connector that you go and make, so to speak, the order doesn't really matter. It's more important on the second connector. So whatever order you chose on the first connector, it is important to make a note of that, even if it's just mental note, so that when you get to the second connector, you know what order you used on the first connector. Otherwise, that cable is not going to work. Now, in some countries, I wouldn't say it's a law. It might be, but it's normally a regulation to, use a certain code. In other countries, I wouldn't say it's a law or a regulation. It's more like a common decency or a courtesy amongst us IT people to go and use a certain code. So in other words, you always start at the same colors and you always end at the same colors. So that way you make it easier for your fellow colleagues, your fellow people in IT, when someone else comes to that client and needs you to do troubleshooting, they can identify a lot quicker and a lot easier what the possible problem might be. Now there's 2 kinds of connections you get. You get your T568A, your T568B. Sounds very fancy, but it's actually very straightforward. Now, if you look at those little connectors I've got there down at the bottom in the middle, that is the standard codes we normally go and use. That is a crossover cable. Now, the one on the left, we're going to start with an unsolid color. We normally start with an unsolid color, one that's got stripes, in other words, which is green. Green, white, to be more precise. We're going to start with green, white, green, orange, white. That's the actual code order that you need to remember. That color code order is what you need to go and remember. And on the second connector, which is the one on the right, that's the other side of your cable, that is the order. Now, why does it not look exactly the same? It's because this is 10 to 1, what we call a crossover cable. Now, something a lot of people don't know, out of those 8 little copper pins, some of them are senders, some of them are receivers, and some of them are basically just used to, well, I suppose, speed it up. Now, pin number 1 and pin number 2 are senders. Pin number 3 and pin number 6 are receivers. And then pin 4 and 5, 7 and 8 are just there, well, for speed. Now, if you look at the connector on the left, specifically pin number 1, what color is that? That is green white. So pin number 1 is a sender. And a sender needs to go to receiver. So 1 and 2 are senders, 3 and 6 are receivers. So if pin number 1 is a sender, it needs to go to a receiver. What is a receiver? 3 and 6. So pin number 1 on connector 1 is going to be the same as pin number 3 on the second connector. So if you check there, pin number 3 on the second connector is the green white because 3 is a receiver. Pin number 2 is also a sender, and that's green. And a sender has to go to a receiver. Now we've already used pin 3, so what's left? Pin 6. So number 2 is going to go to pin 6, which is a receiver. 4 and 5 is going to stay the same because that's just for speed. So you can see 4 and 5 remains the same color. And 7 and 8 is going to remain the same color. Now if you take the second connector and you do the exact opposite of what we just did now, you're going to see the same applies. So looking at our second connector, the one on the right now, look at pin 1. What color is pin 1? It's orange white. That is a sender. A sender needs to go to receiver, which is pin 3. If you look at the first connector, what is pin 3? It is orange white. Now if you look at pin 2 on the right hand connector, that is orange, which is a sender, which needs to go to a receiver. And what is a receiver on pin of the first connector? 6. So pin 2 on the second connector is going to be the same as pin 6 on the first connector, which is now obviously orange as well. So you see where we're going of this. That is a crossover cable. It's not so required or compulsory these days that we have crossover cables. Nowadays, you can go and make what we call a straight, which means pin 1 is going to be the same on both connectors. Pin 2, pin 3, pin 4, all 8 pins will be the exact same color, on both ends. So pin 1 can be any color you want, but it needs to be the same on both sides. So if I choose green white for pin 1, it's going to be green white on both connectors on pin 1. If I choose green for pin 2, it'll be green for both connectors. That is a straight. Straight means it's going to be exactly the same on both sides. Crossover is when your senders need to go receivers and all that. This used to be very common in the old days because in the old days, devices were not very clever. They were pretty stupid. So a sender needs to go to receiver, otherwise you would have collision, with your data and all that. Nowadays, data is, way more complex than that, and our devices are way more advanced than that. They can automatically go back and forth between sending and receiving. They automatically convert themselves. So technically these days, if you have a new PC or a new device, it doesn't really matter what cable you use. You can use either or, and it's going to work just fine. So, but it's still a good, idea to know how these cables work because you never know. Some devices might still be old, and you might still need to go and use these little cable coding and all that. So how do you actually make a network cable? So the first thing you need to go and do is you take that network cable, you take your crimping tool, and you cut off about 1 inch, more or less. It's about the size of your thumb, give or take, or the size of your pinky, kind of. So in centimeters, that'll be about 1.5 centimeters, give or take. So it's give or take 1.5 centimeters, that's just an estimate that you're going to go and open. So you're going to basically cut off that little insulation that covers the 8 little wires. Cut that off about 1 inch or 1.5 centimeters if you're using the metric system. Your cable crimper normally has a special little blade that allows you to close that little crimper tool without cutting off the whole wire. It's really literally just going to cut off the outside coating, of that plenum. You just spin it around, 360 degrees, and you're going to see it's going to come off right off. Now, it's not set in stone. You don't have to use that crimping. You can actually go use normal scissors or something, but then you need to be careful because if you cut down too hard, you could potentially damage the 8 wires inside. So it's advisable to go get yourself a crimping tool. They are really cheap and very easy to come by. Once you've got your 8 wires exposed, get them as straight as you possibly can, because all 8 wires, as you guys know, are normally twisted around one another. Brown and brown white are going to be twisted around one another, to obviously prevent EMI and crosstalk. Green and green white, orange and orange white, blue blue white, they're all going to be twisted around one another. So the first thing you need to do after getting that little coat off is get your wires straight. So use your fingers, get them as straight as you possibly can. Now some of them might be slightly longer than the rest of them, that's fine, as long as you get them straight. So that's step 2. Step 2 is get your wires as straight as possible. If this is Cat 5, category 5 or Cat 5E, it's going to be a lot easier to go and do this versus doing this on Cat 6 or Cat 6A. As you guys might remember, Cat 6 and 6A is a little bit fatter, is the word I used. It's a thicker cable. So it's still possible to do that with your fingers, but it's going to take a little bit longer because the copper inside those little 8 wires is a little bit thicker. It's a higher gauge cable. Step 3. Make sure you've got them in the right order. So step 3, by now you would probably have all 8 wires straightened out. Now once you've got your 8 wires straightened out, get them in the right order, because you're about to go and put them into that little connector. So you're going to get them in the right order. Once you've got them in the right order, hold them very tightly against one another, even though they might not be the same length. That's fine. They're probably not going to be the same length. If you start arranging them in your fingers and you get them in the right order, chances are they're most likely not going to be the same length. That's fine. Just get them in the right order, hold them tightly, because step 4 is going to be to go and cut them evenly. So here in this picture, you cannot see someone holding them, but realistically, you're going to be holding on to those 8 wires. Otherwise, they're going to move out of place. So you need to keep your fingers tight on those little 8 wires. Keep tight grip on those 8 wires. And there's a special blade in your crimping tool that cuts them off exactly evenly. So as soon as you cut those 8 wires, don't let go of the 8 wires. Otherwise, they're going to move out of place and you're going to have to redo the whole process. So hold on to those 8 wires. Step 5, while holding on to the 8 wires, you slide them into the little transparent connector. So you can see here it's upside down. On the bottom of that connector is where you're going to find the little clip, the little button you press in to release this little connector out of whatever port you slide into it. So here, if you see the little copper points, you can see those little copper contact points of that connector is facing towards the top now. The one way on the left is pin 1. The one way on the right is pin 8. So those 8 wires, I know it's not perfectly clear here because this is a cartoon image, but the one way on the left is actually orange-white. So orange-white in this scenario is going to go into pin 1. Orange is going to go into pin 2, and obviously blue-white is going to go into pin 3 there, and you see the whole pattern here. So as you keep them, as you keep a very tight grip on those little 8 wires, hold tightly onto them and gently, ever so slowly, slide them into them. About halfway through, you're going to see they're automatically going to just slide into little channels there. It's like little transparent channels. It's not visible really, but they're automatically going to guide them into the correct channels there. Now, once you've got all 8 wires in there, make sure they're still in the right channels before you go ahead and crimp them. So as you slide them in there, it happens, 1 out of 3 times. With one of them might actually move, swap places with another wire. If that's the case, just slowly pull it out, rearrange your wires again, check the length that it's still more or less the same. If it is, try again for a second time. Normally the second time you're going to be lucky. Step 6 here is, as you keep a very tight grip on those wires, you slide that little RJ45 connector with the wire into your crimping tool while the crimping tool is open. Once the crimping tool is open and once you've got your little connector in there, you press down with your crimping tool as hard as you possibly can. Now what that's going to do is it's going to basically hold your RJ45 connector in place, and at the same time it's going to press down on those 8 little copper pins of yours. It's going to press them down, which is going to force those little copper blades, so to speak, to cut into those 8 little wires and make contact. Once it does that, that wire is not going to come out because it's going to basically fuse them, if you will. Now, once you've done that, you're actually technically done. All you need to do now is just verify that all 8 pins have actually been pressed down. So you can check it from the bottom, you can check it from the side because it's all transparent, and with reason, because this allows you as a technician to see if it actually crimped successfully. If one of those 8 little pins have not, gone all the way down, you simply just push it back into your crimping tool and just do it again. Alternatively, you can use a very small flat screwdriver and just manually push it down with a small little flat screwdriver. That also gets the job done. That's all you need to go and do. Now all that's left to do after you've crimped both connectors successfully is to obviously go and test it. So there's a picture of the connector. I've thrown that in there for you guys as an extra, just so you can see from the side it actually is transparent. So there's your 8 little connectors at the bottom right. And you can see, I know it's not clear, but you can see they actually look very sharp. So that is an unused one. And if you were to go and slide your little 8 wires in there and press, on those little copper pins, it's going to push them in and make them basically cut into those wires and make contact. Alright, so just a little recap. As for normal straight through cable, as we've discussed, that's the one where the cable colors look the same on both sides. Doesn't matter what color you use. In most countries, some countries I suppose might have a regulation or a law, although I find that unlikely. So it is just a courtesy, I would say. It's more courtesy amongst us IT people to use the same code so that you make the next guy's life so much easier if you use the same code. Now, if you don't use the same code, you just used whatever color order you wanted, that's fine. It's still going to work. It's not going to be a matter of it's not going to work. It's still going to work. It's just if the next technician comes there and they need to go and troubleshoot, it's going to take them slightly longer to be able to verify what the problem is. So it's just going to make it a little bit easier for the next guy. That's all you want to achieve here. Anyway, so yeah, straight through cable has some termination at both ends. So it's same termination at both ends. Same color is what they're saying. Crossover cable is where pin 1 goes to pin 3, pin 2 goes to pin 6 on both sides. And then obviously, pin 4 and 5 and 7 and 8 doesn't matter. That's just going to be the same. All right. So with regards to crossover cable, as you can see, previously used for direct connection, so directly between my machine and your machine or something like that, nowadays, it doesn't matter because they automatically convert. So now gigabit Ethernet interfaces can automatically cross over with standard cable. You do not need a fancy cable. You can use either or, and your technology nowadays is smart enough to see that, oh, I'm using straight, or smart enough to see, oh, I'm using crossover, and they'll automatically adapt. So yeah, I mean, they're both very common. I would say actually, in my opinion, straight is a little bit more common nowadays because the average Joe nowadays does not know how to make a crossover cable. Some of them are just plain lazy, so they do know how to make it. Some technicians are just lazy. But in my opinion, based on my experience, more than half of technicians, even though they've got a lot of experience, don't actually know how to make a crossover cable, even though it's actually easy as pie. Now, whether you're going to go and use this in real life or not is a different story, but you do need to understand this for the exam. It's absolutely crucial because this will be in the exam. You are going to be expected to know what an Ethernet cable is. You're going to be expected to know what its range is, what the different kinds of speeds it is you get, what categories you get. You're going to be expected to know what crossover is, what the difference between straight and crossover is, and you're going to be expected to know with regards to crossover which pins goes to which pins. All of that is something you need to know for your exam. So I'm giving you guys a lot of exam tips in this specific module. Whenever I see something that I know is important for the exam, I will point it out for you guys as a courtesy. Alright, so since we've talked so much about network cables, let's talk a bit about patch panels and structured cabling. Now, you guys might see this in real life, you might not see this in real life. Why I'm saying that is because a lot of things are moving towards virtual nowadays. Everything is moving towards the cloud. Everything is moving towards virtual nowadays. So less and less are we seeing servers physically on premises, and less do we need all of those kinds of cabling. So patch panels is basically a means, for us to go and connect different departments and different divisions to one another. It's a way for us to quickly go and organize stuff. It's a way for us to quickly go and connect different departments with one another, like I just said. And in the event of me needing to go and troubleshoot, it's going to be a lot quicker. So all of your different departments and different people, all of those cables are going to come together in most likely in your server room. You're going to have your switches there and your patch panels. And from the patch panel, there's going to be a very small, short little network cable. We call these fly leads. That fly lead or short network cable is going to go from the patch panel into the switch. So if there's a fault on the network, it's going to be a lot quicker to go and troubleshoot there by the patch panel than having to go and trace that long network cable. In a nutshell, it's just there to make your life easier. I wouldn't say it's absolutely crucial to have them, but it does make troubleshooting a lot easier in any company network, and it does make network management a lot easier. So I suppose it's kind of a must-have, because these days networks are so darn gosh large in some companies. I can't imagine a company without using patch panels. All right, folks, so we're going to take a look at some tools we can use for troubleshooting and testing and just general installation of your networking environment. The first one up here is the wire stripper or the wire cutter. This is generally something that most of us technicians will have in our toolbox. It's not something you're going to use that often because your cable crimper is normally going to do most of your work. There are situations where you might require this though. I myself do have one, but honestly speaking, I almost never use it. So it's used to go and strip very small pieces of wire. So this is more suited for electricians, for electrical wiring, which is why we computer technicians don't really use this one that much. So it's better suited for, I suppose, electrical wiring, just stripping. Then we have a punch down tool. I've got more than one picture there for you guys, just to make the picture a little bit more clearer. The one on the right is actually the one I see more commonly. It looks very much like that. And towards the top, you'll see there's like a little wheel, a little gray wheel. It's not necessarily going to be gray, but in this picture, it's gray, which allows you to go and choose, the pressure. So what this thing does is it allows you to go and punch down those little 8 wires into something like a network wall box or into a patch panel. I'm going to show you guys a picture of a wall box now just after this and a patch panel just so you have an idea. So those wall boxes are those little boxies that you'll find sometimes in some companies underneath your table, or it might be against the wall somewhere in your office. And the idea is for you to plug a small short little network lead, a small little network cable from your laptop or your desktop into that little wall box. Now, why do we use those wall boxes? Well, in the event of you breaking your network cable, this happens, sometimes they get worn out. Sometimes some of these office chairs, they've got wheels and you accidentally go over that network cable a few times and, well, you break it. And even when that happens, wouldn't it be easier for us just to have to replace that small little network cable from your PC to the wall versus having to change the whole network cable all the way from your machine, all the way through the walls and the roof, all the way to where eventually wherever it terminates, which might very well be the server room. This could be 100 meters or more away for all we know. So that's going to be a lot of work, a lot of effort, and very time consuming. So the reason why we use those wall boxes is many reasons, but the main one is it's a lot easier and a lot quicker to go and have to replace that small little fly lead, we call that a small little patch lead or a fly lead, from your computer station to the wall. It's going to be about 1 meter, maybe 2 meters, maybe about 10 feet, give or take. That's a lot quicker and a lot easier. So that little wall box, the network cable, on the side in the server room is going to have an actual network connector, an RJ45, which is going to plug into a switch or a patch panel. But by your wall in your office, wherever this little boxy is, it's not going to be a second RJ45 connector. It's going to be a little wall box. You're still going to use the principle of those little 8 pins. I wanted to say pulls. So pin 1 still goes to pin 3, pin 2 still goes to pin 6. So you need to remember what color code you used on that connector in the server room, because in that little wall boxy, you're going to need to apply that to those specific pins. Now the places where you need to go and put those little wires in are luckily numbered inside that little boxy. So how does the box look? For those of you that's never seen it, it normally looks like that in most office environments. And what it looks like on the inside is more or less like that. You can see they are numbered. So what you're going to have to do is, once again, straighten out your wires. You don't need to straighten them out as much as you would do with an RJ45 connector, but just basically untangle them. Untangle them, and then from the top side of that right hand picture, that cable is going to come in there, and you're going to take your 8 little exposed wires and put them in the right order to the right pins. So you put blue on the right one, orange on the right one, and all that. You slide them down, and you can use either a very small flat screwdriver, or you can use that punch down tool, which is going to press that wire between the little copper pins, which is going to cut the wire as well. And what the punch down tool does, it doesn't just press it down between the blades so they cut into the little wiring. It also cuts off the excess cable, making it look very nice and tidy. So this is how we do it. On the left hand side, you first put the wiring into those little connectors, as you can see there. They're more or less where they need to be in those little channels. They're not all the way down yet though. So you could go and use a little flat screwdriver, a very, very small flat screwdriver, and force them down all the way down the channel. And those little copper blades inside, which you guys can't see visibly in this picture, are automatically going to cut into those cables. Once again, making contact like your RJ45 connector. However, if you do it with a flat screwdriver, you're going to still have excess cable, dangling about. So you might have to use a side cutter or that wire stripper or some scissors, just to make it look neat and tidy. If you use the punch down tool, it presses them down into those channels, and not just that, it automatically cuts off the excess cable, which is pretty damn nifty, I must say. Here's a picture of a patch panel for you guys. So there you're also going to go and use that punch down tool. So punch down tool is something you're going to go and use on a wall box or in a patch panel. Basically, both of them are very common, So you're guaranteed to use this somewhere along the line. And this tool is also a must-have in your toolbox as a technician. Speaking of tools that's a must-have, this is probably one of the most important tools to have in your toolbox as a technician. That is the actual crimping tool I've been talking about. They come in many shapes, many sizes, many colors, many designs, but they all do the same thing. They crimp an RJ45 connector. Now, 9 out of 10 of these crimpers will normally have an RJ11 port as well. So if you look at the one on the right there, at the top port there, it says 8P. I don't know if you guys can see it clearly, but it says 8P. That means it's an 8-pin connector, being your RJ45 connector for your normal Ethernet network cables. The other one there says, I don't know what it says. It looks like it says 6 pins, but it's actually 4 pins. That's normally for an RJ11. That's for your old telephone lines. So unless you're a phone technician, you're probably not going to be using that. That's for your old telephone lines, which uses cables called POTS. POTS. Plain old telephone system. I'm saying that because that's a question in the exam. They're going to ask you, what is POTS? Or what does the old telephone system use? It uses a POTS line. Plain old telephone system. What connectors does the old telephone system use? It's an RJ11. Now that POTS line, believe it or not, is actually also called a CAT. It's category free, cat free. It's cat free, category free, or also known as a POTS line. Now, Cat 5, Cat 5e, Cat 6, Cat 6a, those ones are all normal networking cables. The ones that all require an RJ45 connector. Alright, so once you've made a cable, or once you get to someone's desk and they might possibly have a faulty cable, there are some testing steps you guys can go and apply. Now, these are not all the steps, but these are the most common steps you can go and apply, and generally these ones will get the job done. So imagine yourself coming to a user's desk. It might be one of your clients, it might be one of your company's users, and you suspect that the cable might be faulty. Maybe they're telling you something along the lines that my internet is off, or it says my network cable is unplugged, even though I can clearly see it's plugged into my PC or my laptop. That's an indication that it's probably something wrong with the cable. So the first step there is verify wiring installation and termination just after making connections with access to cable runs. So what you should go and do is plug out the network, that RJ45 connector, make sure all 8 pins are connected. Now, if the cable did previously work, you can actually ask the user questions. So I normally encourage you to ask the user questions. So ask the user questions like, has this cable worked before? If it has, then it's unlikely it's going to be one of the 8 connectors because they probably have been, pressed down all the way if they worked previously. It's not going to go back. If the cable has never worked, then there is a chance that it might not have been crimped properly. So verify that all 8 wires are in the right channels. Verify that all 8 copper pins, or whatever those pins are made out of, verify that they've been pressed down all the way. So just double check that as well. Also verify, never mind that the cables are in the right order, verify that they're pressed in all the way. Some people, they don't cut the wires, making them equal length. They press all 8 wires into that little RJ45 connector, and they crimp it, but they didn't actually make sure that all 8 wires have gone in all the way. That's also going to cause issues. Step 2 is simpler than during the user test device. So yeah, you are going to go and check the cable first. Make sure it's plugged in, make sure all those connected, all the things we've mentioned, because that's going to be a lot quicker and a lot easier versus having to go and check the PC settings and all that. Normally, we are going to go and use a concept called least amount of effort. Least amount of effort is the quickest way. We always start at the steps that's the quickest and the easiest, and we work our way down the grapevine, so to speak, until we find a solution. End of the day, we want to get this user back up and running as quickly as possible. So it's not because we're lazy, it's because we want to get this person back up and running, or get the service back up and running as quickly as possible. So you always start with the method that's the least amount of effort. Also, consider the patch cord between the PC and the panel, or the PC and the wall. They're talking about the fly lead there. So it could be that maybe that small little cable is just faulty, the one between the machine and that little wall box we spoke of earlier. So what you could go and do there is you could maybe just go and use a different cable. That's the one way to go and test if it's the cable. Get another network cable, plug it into that machine, plug it into the wall. If the other cable works, the new one, well, then the old one's obviously faulty. At least then you can just go and throw it away and get a new one. They also mention check the port on the patch panel and the patch cord, and check the ports on the switches. That is going to be, lower down the grapevine, I would say. That's not going to be the first things you're going to go and check, because that's obviously going to take longer. But if one of the previous methods have failed, I would say go to the server room or wherever this patch panel on the switch port is, and plug out the cable wherever it connects in the server room or the patch panel, plug it out and plug it into a different port. If you plug it into a different port and the problem goes away, well, then it's that port that's faulty. Sometimes these ports blow. Now, in most cases, from my experience, the whole switch would blow or the whole patch panel would blow. Normally switches blow, not patch panels. But there has been occasions where I've actually had it where just the port would blow. And by switching to a different port, you resolve that issue. So it might not be necessary to change the whole switch or the whole patch panel if you have a few spare ports open. But if you do not have a few spare ports open, and you swap cables and suddenly that cable works, then well, you've got a faulty switch or a faulty patch panel, and you need to replace it because you have no spare ports, and you're going to need that extra port. Alright, more cable installation and testing tools. Here, my friends, we've got a multimeter. Not something you guys are going to really use that often, especially if you guys most likely being into computers or servers. This is more something you're going to be using as an electrician. Doesn't mean we don't use it at all. It's still a nice tool to have in your toolbox. And the one we've got there in that picture is something you find in most countries. It's a very cheap one, and it gets the job done. You don't need the world's most expensive multimeter. You can go get yourself a relatively cheap one from computer stores, hardware stores. You can get these pretty much just about anywhere. And you never know when you need to go and check if there's a current, and if so, how much the current actually is in volts or watts. Maybe you need to go and check what the resistance is. Maybe you just need to go and check if there's a fuse that's blown. You can use this for quite a lot of things. Still a very handy tool to have in your toolbox. Now, for exam purposes, all you need to know about this tool is it's called a multimeter, and it's used to check things like voltage and resistance. That's all you need to know for exam. They're not too concerned about this in exam, considering that it's more about electricity, and electricity is not exactly something we technicians work with, since we are computer technicians. Our next tool up here is a cable tester. So I've got the same descriptions there on the left hand side, so just ignore that, I was a bit lazy. So this tool is a cable tester. I wouldn't say it's a must-have in your toolbox, but you're probably going to end up using this tool more than the previous multimeter we had. Now, this picture is not the best picture, so what it has there is you get this in many shapes and sizes. They also cost about more or less the same as that cable crimper. They're not that expensive. I can't give you an exact amount because it depends on what country you're in. It might vary from country to country. Now, I don't know if you guys can see it in the picture, but that part on the right is actually detachable from the part on the left. The part on the left has a little switch there which allows you to turn it on. There's 8 lights on the left, well 9 actually, but there's 8 main ones that you're going to be concerned about. And there's about 9 lights on the right hand side. It's the 8 numbers that you need to be concerned with. So on the top side of this little thingy, there's actually 3 ports. On the bottom here, you can see there's only 1. Now that port on the right that's detachable has a port on the top and a port on the bottom. One of the 2 ports is an RJ11 port. The other port is an RJ45 port. Now the box here on the left, the bigger one out of the 2 that's got the switch, on the top it's got 2 ports. Also an RJ45, also an RJ11. So it can be used to test phone cables, and it can be used to test network cables, is what we're saying. So if it's a phone cable, you're going to plug it into that RJ11 port on the top of the left box. And that little detachable box, on the right hand side, you just check which one of the 2 ports is the RJ11. It can only go into one of the 2 ports. It's not like you can plug it into the wrong port. It can only fit into one. You plug it into the right port there, and you can go and test the cable. Same applies for RJ45. Now let's assume it's an RJ45 because you guys are network technicians. That's what you're going to be working with. If you plug it into both ports, both RJ45 ports, if it's a straight cable, you want to see all 8 lights coming on, and you want to see them come on at the same time. So what's going to happen here is, if you put it on slow, you can actually choose the speed at which these lights normally flicker. Port 1 is going to come on. The number 1. You can see there's a number 1 and number 2 and number 3 on both sides. The light for number 1 is going to come on the left hand side, and the exact same time on the right hand side, you want to see the number 1 come on. That is if it's a straight cable. Straight means 1 goes to 1, 2 goes to 2, pin 3 goes to pin 3. The exact same colors are being used on both sides. So when light 1 comes on the left, light 1 needs to come on the right. And then it's going to move on to the next light. It's going to test those cables one by one. There's 8 wires. Each gets tested one by one. So it starts with number 1. Then it starts with number 2. So whenever light 2 comes on, it needs to come on both sides. Then number 3, then number 4, then number 5, then number 6, and number 7, and number 8. Obviously so on. So if one of those lights comes on the left, but it does not come on the right, then you know that cable is faulty. Now with regards to a crossover cable, all 8 lights still need to come on, but not in that exact order. So if light 1 comes on the left, light 3 needs to come on the right. So you still need to see a light on the right. That's the first thing you need to look for. Look for a light and make sure it's the right light. So if 1 comes on the left, you want to see a light on the right, and it needs to be light 3. If you see no light on the right hand side, that means the cable is faulty. If you do see a light on the right hand side, but it's any number other than 3, that means the connector is incorrectly crimped. One of the wires accidentally went into the wrong channel when you crimped it. So that's also an indication. So you can test whether the cable itself is working and whether it's actually been crimped correctly. Now if light 2 on the left comes on, remember 2 goes to 6. 2 is a sender, 1 is a sender, 3 is a receiver, 6 is a receiver. So if light 2 on the left goes on, that means it's sending. It needs to send to port 6 on the right. So if you see light 2 on the left is on, light 6 on the right needs to be on. Any other light other than 6 on the right that's on is going to be incorrect. Now on the left hand side, if you see light 3 on, that means light 1 on the right needs to be on. On the left, if you see 4, on the right it needs to be 4. On the left, if you see 5, on the right it needs to be 5. And then we get to 6 again. So if you see light 6 on the left, that means you need to see light 2 on the right on. And then 7 and 8 is once again just the same. So 7, 7, 8, 8 needs to be the same. That is how this cable tester works. It's very straightforward. It's very easy. Very nice tool to have in your toolbox, but I wouldn't say it's compulsory. There is other ways you can go and test an network cable without having one of these in your toolbox. But if you're on a tight budget, you don't need to have one of these. There's other ways around it. Alright, and then you get something that's called a tone generator, or aka Fox and Hound. I normally know it as the toner probe or the tone generator. Now, this is a nifty little tool. It looks like a magic wand, if I'm being perfectly honest. I don't have a picture for you guys today, but it allows you to locate cables, faulty cables. So to give you guys an example, let's say I need to trace a cable and I don't know which one it is in the server room or the network cabinet. So I'm going to start plugging this little tone generator into the network point, maybe in someone's office. So maybe I'm going to come into your office. You only have one network cable in your office. I'm going to plug my tone generator onto that little cable on your office, that one cable. And I'm going to have my magic wand. I don't even need to touch the cable. If I hover my magic wand near that cable, it's going to start making a loud tone, like a beep. You're going to hear a loud tone whenever I hover my little magic wand near that cable, because it's generating a tone into that cable. Now where it comes handy is I'm going to go into the server room or the network cabinet where my hundreds and hundreds of cables all come together, and I have absolutely no clue which cable it is. Now you might say, can I just go and unplug and plug one of them, one by one in? No. Generally in a real company environment, you cannot just go and willy-nilly unplug cables and plug them in, because you could very well bring something down. You probably are going to bring something down. So when you plug something out, the first guess needs to be correct. If you guess just once wrong, that's going to be a problem. So now if I go to between all of those cables in the server room where they all come together, as soon as you hover your magic wand near that cable, it's going to start generating that tone. So you're able to follow that cable actually through walls even. It's going to generate that tone through the walls. You can see where in the wall it's going because it's going to generate that tone. And when you get to the server room, you just hover it, and when you get near the correct cable, it's going to generate that tone. So it's used to trace cables. Most technicians don't actually have this tool. I've never had this tool in my life. I wish I had, because it would have made my life so much easier. And I think it's because it varies from company to company. Some companies believe, no, that's a waste of money. You can go and trace the cable old school yourself. Can be done, but it's going to take you a lot longer to do it. So if your company is willing to buy you one of these little doohickeys, it's going to make your life so much quicker and so much easier when it comes to tracing a cable where you have a lot of cables and you don't know where they're going, which is which. Alright guys, so here we have what we call a loopback plug. This is used to test ports. Now you remember earlier when we discussed network cables, this is why this topic is afterwards. Port 1 and 2 is a sender, port 3 and 6 are receivers. Now look at what these guys did there. They took port 1, they actually shoved a tiny little wire into port 1 and that little transparent connector, and at the same time they looped it back into port 3. So within the same connector it's loop-de-loop. Port 2 is automatically going to port 6 within the same connector, so that's causing a loop. Depending on what you plug this into, it can actually bring your network down. Nowadays it doesn't happen that often because most of our network devices, switches and stuff are clever enough. But about 10 years ago, if you used to go and plug something like that into a switch, it's going to cause a loop in that switch. And it basically sends the same signal in a loop, 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 loop in that switch. And it's going to bring your network down. It times out. The switch basically freaks the hell out. It brings the whole network down. Your whole building can actually potentially be down. That's how you crash a whole building. Nowadays, that doesn't actually work unless you're using very old network hardware. It's probably not going to work. As soon as it sees there's a loop, it drops that connection or turns that port off. Now, this can be used in other ways to go and test networks. So you can, for example, take that small little connector, plug it into your computer's network port, and it can be used to test your network port to see if it's actually functioning correctly. It's not something I see happening often. Most of us don't even have this. But if the need arises, that can be used as an alternative to go and test a port that's faulty or that you suspect is faulty. Okay, so let's take a bit of a look at a different kind of cable, being fiber optic cable. Now, this is something you guys are probably going to see quite often, at least where we are right now at this point in time, with most people using fiber internet. And fiber is actually very commonly used in a server environment as well, something you guys might not have known. Now, with regards to fiber, you get two kinds of fiber. You get single mode and you get multi-mode. Now we're going to have that in just a second, but single mode is generally used for long range. So that's kind of like the fiber cable that's going to be between buildings. Maybe the fiber cable that you're going to see outside is going to come to your house or your office building that provides internet to your home. That's generally long range. So that's normally going to be single mode. Fiber is also used internally. So this is obviously a very, very fast kind of cable. And if you're going to be using it internally, well, you normally use the multi-mode one because that's short range. So this is a great way to go and connect different servers to one another or different components in your server room to one another, because this kind of cable is generally a lot faster than your network cables. It's usually even faster than your Cat6 cables. So that is why we use fiber cables. It generally costs more to install those, so which is why so many companies don't actually use it, because it's expensive to go and install. The cable itself is not the most expensive part. It's normally the actual installation itself, because unlike a network cable where you just need a network crimping tool, with fiber cable you normally need a splicer. And this fancy splicing tool basically just fuses cable. It's a special fuser, if you want to call it that. So if I've got two pieces of fiber cable and I want to connect them to one another, I'm going to go and splice it. And the term splicing simply just means I'm fusing those two cables with one another, or I'm fusing that fiber cable to something. Now, fiber cable, never mind it being, able to transfer, over very great distances. I mean, we know a network cable can generally go maximum 100 meters or 328 feet according to the manual. Obviously, it's less in real life. Fiber cables can go kilometers and kilometers or miles and miles, much, much further than a network cable. So you can go and transfer data over great distances. That's one, benefit. They make use of glass versus copper. There's benefits to that. Copper, obviously, you can go and interfere with that. We talked about EMI earlier in this module. So if you've got a copper network cable or any kind of copper cable, interference is a possible problem. More specifically, EMI is a problem, electromagnetic interference. So if you bring that network cable of yours, your normal Cat5, Cat6 kind of cables, near any form of electricity or power cable, EMI is going to pose a problem. If you bring that network cable near any heavy machinery, EMI is going to be a problem. If you bring that network cable near fluorescent lights in the ceiling, EMI is going to be a problem. But if you've got fiber, never mind it being so fast and being able to travel over great distances, EMI absolutely does not interfere with it at all, because it uses glass. Glass is used to reflect light. So instead of it being an old conventional, current, through a copper cable, this is light that reflects inside glass, which is why and how it's able to travel over such great distances. The signal also doesn't degrade. You can see it's mentioned there in my bullet points. It doesn't degrade. With a network cable, according to the manual, it only goes to 100 meters, or let's say realistically it's about 70 to 90 meters. After about 70 to 90 meters, realistically in real life, you're going to have to rebroadcast that signal. According to the manual, you're supposed to use a repeater. Realistically in real life, we know it's going to be a switch of some kind. It's going to just give it an extra oomph, a little nudge, just boosting the signal again. So fiber doesn't need that boost. It can go great distances, so it doesn't degrade as quickly the signal. It doesn't get so weak so quickly the signal, is what we're saying. And then lastly, obviously, fiber is just tremendously fast. Now, as for the two kinds of fiber I mentioned, you get single mode fiber, in other words, SMF, and you get multi-mode fiber. Now, you do need to know both for the exam. All you need to know for the exam is single mode is for long distance, in other words, outside. That's used for WANs. So if you want to connect different buildings to one another, this could be in the same town, could be even further than that. That's going to be your single mode. So think of it as internet to your house or internet to your office building. That's going to be single mode. Multi-mode is shorter distances, and that's going to be within the building, probably within your server room 10 to 1. So you can see that it's suitable for LANs. Another kind of cable we get, and this is actually something fairly old, is coaxial cable. Comes in many shapes and many sizes, but what they generally have in common is they've got a solid core, generally made out of copper, but it could actually be stainless steel or something like that. What you preferably want is the one that's made out of copper, because it's a better conductor. So some of them might be made out of steel. Some of them might be made out of steel with a copper plate around it. That's the core itself. The braiding around the side could either be steel, or it could be copper. So copper is the best quality one. Signal is just going to be so much better, but it's also going to cost you more. So depending on what you're going to be using it for, if you don't need to have such a good signal, and if it's not for something so important, you can get the cheaper quality one that you can pick up at your local supermarket, which is probably going to be steel. If you're going to get the higher quality one, that is for something that where you require a very high quality signal. So yeah, that's pretty much coaxial cable. In the old days, we used to use these as TV antennas. Depending on which country you're in and what your TV looks like, there would normally be an antenna port, for those old bunny ears kinds of antennas and stuff you used to get. We don't actually use those anymore, but some countries might still use them. We used to use that. That's one kind of coaxial cable. In some countries, we also use these as decoder cables. The one that's going to hook up to your dish outside on the roof or outside against the wall, which is going to give you some sort of digital television. That's also a form of coaxial cable. The actual connectors you connect to these coaxial cables, you get different kinds, but the most common kinds I've seen is an F connector or a B and C connector. But you do get other ones as well. So how do these connectors look? Kind of something like that. That's not the only ones. That's not the best example. But it's more or less an indication as to what you can expect with regards to an F connector or a B and C connector. You also get other kinds of connectors, obviously, though. Alright guys, all this talk about network cabling, Ethernet cables, fiber cables, coaxial cables, let's have a bit of a look at the actual hardware where this cables plugs into and actually connects to. Now the first one up here is NIC, N-I-C. It stands for Network Interface Card, as you guys can see. Port provides connection to network media. Each node must be able to address other nodes. Now, the word node means computer, PC. It can be a laptop, it can be a desktop. It usually is, let's just call it a PC. I want you guys to get comfortable and familiar with the word node because they like using that in the exam. So if you don't know what the word node means and the question says something about nodes, you're not going to understand the question. Meanwhile, they're asking you something very simple, something that you actually do know the answer to, but just because they use the word node and you don't know what the abbreviation means or what the analogy means, you're not going to understand the question. So yeah, NIC means network interface card. Get familiar with that one. Node means computer. Now, what is the network interface card? This is an actual physical card in your computer which allows your computer to connect to a network cable, and it allows it to communicate with other nodes. In other words, other computers. Now, if you go check behind the box, the average computer desktop PC, they normally have this network port being the RJ45 port. It's physically embedded on the motherboard. So the chances of you having to install a card like you guys see there right now is unlikely. Normally your motherboard already has this embedded. And the same applies to laptops. Laptops normally have this embedded in the laptop. Now, in laptops, you can't normally really go and change the actual 45 port, the RJ45 port, but in some cases, you can actually go and remove the wireless network adapter. So your laptop normally has two adapters, one that allows it to connect to RJ45s and one that allows it to connect to wireless networks. The wireless one is in some cases a small little card that's actually removable. You can remove it and you can swap it. The actual RJ45 port is a whole different story. So that you are stuck with what you've got. If it breaks, it breaks. Desktop PCs, however, if you need an additional port for whatever reason, or if your RJ45 port is faulty, you can go and put in one of these cards. You slot one of these into those white PCI slots. It's usually white in color, but it's not set in stone. Theoretically, it could actually be any kind of slot, or any kind of color, I should say. So as soon as you plug a network cable into that port there, those little lights there that you guys see next to the port will generally flicker, indicating that network traffic is taking place. Some of them will just, stay on to indicate the card is connected. Some of them would flicker to indicate that traffic is actually occurring at that point in time. Now, with regards to network cards, your network card, whether it's embedded in your motherboard or whether it's an expansion card you've slid into one of those ports, it contains your MAC address. MAC, MAC address. That is your physical network address. You can think of this as your ID number or your social security number, which cannot be changed. It is unique ID for your computer. And that identifies you. So we can use that to trace you to a certain extent, or to establish whether you are a criminal in some sort of crime. We can use those MAC addresses for so many things. It can be used as a filter. So if you have a hotspot, in other words, a Wi-Fi at your office, and let's say a lot of people have the password to that Wi-Fi, but you only want certain people to be able to connect to it, you can go and make a note if everybody's MAC addresses, the ones that's supposed to be able to connect to it, and every device has got a MAC address. It can be a phone, a tablet, a printer, anything. So anything that's allowed to connect to that hotspot, jot down their MAC addresses, and you can go onto that hotspot and go and enable a filter. It's called a MAC filter. In that MAC filter, you simply just go and add the MAC addresses for the machines or devices that is indeed allowed. And when any other device tries to connect to that Wi-Fi hotspot, it's not going to work because they don't have their MAC addresses in that filter. It's kind of like a whitelist, blacklist kind of scenario. You can think of the MAC filter as a bouncer. Now in this picture, you guys can see there is a network port. This picture actually looks like more like an internal modem versus a network card, but there's a little network port, and there you've got your little status indicator lights. Now, as for the MAC address, it generally consists of 48 bits, 6 bytes, and is shown as 12 hex digits. Now, there's an example for you guys of what a MAC address with more or less looks like. And you can actually find this by going into your computer to command prompt. So if you go type in CMD to open command prompt, and you go type in ipconfig/all, you would be able to find your machine's MAC address. It is listed as physical address there. So if you go and type in ipconfig/all, it would show you your MAC address. It will be listed as physical address. Now, something else we get with regards to networks, which your network cables can connect to, is switches. You get these in many shapes and many sizes, and you get unmanaged ones and you get managed ones. This is a pretty big switch. It looks like a 48 port switch. So this is a pretty big one, which you're probably going to go and use in a company. Very unlikely you're going to be using this in your local household. So small household ones would normally be like a four port switch, 8 port switch, something in that regard. And if you go look at your average router in your house, it normally actually has the switch function built into it. So it's not just a router/router, it actually is kind of a switch to a certain extent as well. So this little switch allows you to connect all of your laptops, desktops, and network components with one another. All you need to go and do is plug a PC, let's say PC1, into a network cable, or plug a network cable into PC1, plug that cable into port 1, and you go to the second PC, you plug a cable into that PC, and you plug it into port 2, and so on and so forth. This switch is going to be the central point which connects them all together. Now, assuming on those PCs that all network configuration is correct, like the IP address and all of that kinds of things, like network discovery, your machines would effectively be able to communicate with one another. That is what a switch is. It's a central communication device that allows your machines to communicate with one another. Now, it does look very much the same as a hub. A hub looks pretty much identical to a switch. However, a hub is a dumb device. A switch is a smart device. A switch allows you to communicate with one individual person on a network. So if there's 48 PCs plugged into the switch and I send you specifically something over the network, only you will get that certain document or file. Whereas compared to a hub, it might have 48 ports, everybody's connected to one another, but when I send you something, that hub broadcasts that something. So it's going to basically give that document or that file to everybody. So there's absolutely no confidentiality. So it's kind of like you telling me a secret and I just, say it out loud so that everybody can hear your secret. Not very nice now, is it? So with regards to managed and unmanaged switches, like I've mentioned, unmanaged is normally a lot cheaper. And if you go look at the average one in your house, which is a 4-port, 8-port, or if you go look at your router, that's just a small cheap switch. It's got 4 ports or 8 ports. And in companies, depending on what department this is in the company, if it's just a office of some kind, it's probably going to be a switch that's got a lot more ports. But for the most part, it's probably still going to be an unmanaged switch. An unmanaged switch is a cheap switch. You just plug PCs into it or plug network devices into it, and there you go. Communication is going to occur. A managed switch generally costs a lot more money because they have a lot more functions. You as the administrator can log into that switch. You do it via a web browser, kind of like logging into a router. So you go to your web browser, you type in the IP address of that switch. It allows you to log on with username and password. And once you log on to that switch, that's what the term managed means, you can go and manage that switch. You can do all kinds of configurations. And one of the most common things we do on them is create VLANs, which stands for Virtual Local Area Networks. So if I just go and use an unmanaged switch, it technically has a VLAN, but it's just one VLAN, which means it doesn't matter which port you plug into that switch, everybody's going to be on the same network. Now, if I have a managed switch, let's say this switch has 48 ports, just because it's 48 ports doesn't mean all 48 ports is on the same network, even though it's one physical device. I can go and take port 1 all the way to port 24 and make that VLAN 1, virtual LAN 1 is what it says. And I can go take port 25 all the way to port 48 and make that VLAN 2. So if you're plugged into port 1 and the other guy's plugged into port 24, you'd be on the same LAN virtually speaking. Physically, you're plugged into the same device, but you may very well not be on the same network. So anything between port 1 and port 24, those people and those devices will be on the same network. Now, if I go and take another PC, another person, and I plug him or her into, let's say, anything between port 25 and port 48, that's a different VLAN. Now, even though those two people are plugged into the same physical switch, digitally speaking, they're not on the same network. So VLANs are quite extensively used in any medium to large size organization. And that is something you guys are going to have to get familiar with going forward if you're going to look at N+ and courses like that. Not something you need to be concerned with at this point in time for A+, but going forward in your IT career, it is something you need to get you familiar with because it's definitely something that's used very widely in organizations. It's a way to manage networks. And then we also have Power over Ethernet. Most of us just call it PoE, capital P, small o, capital E. Supplies power from a switch port over Cat5 or better to a power device. Power injector can be used if switch does not support PoE. You get some switches that are never being managed or unmanaged switches. You get switches that's called PoE switches. If a switch is a PoE switch, it would normally be written on the switch itself. Normally somewhere near the port is going to say PoE switch, not just switch. Switch detects if connected devices is PoE enabled. And lastly, more efficient than powering each device through a wall socket. Now, what does it actually do and why would we use this? Let me give you guys a situation. Imagine you've got an access point. We call them APs. An access point is the device that broadcasts your signal wirelessly in the company building or in your house. In other words, it provides the Wi-Fi access. Now, most companies would put these devices on the ceiling or above the ceiling, somewhere in the ceiling. Now, on the ceiling, yes, there's power in there, but it's not exactly sockets that you can go and plug a device into. It's power that's already hooked up to the lights and that kinds of stuff. So that little access point that you've got on the roof now, it needs to be connected to the network. That is easy enough. You simply just plug a network cable into it. The network cable is probably going to go through the roof. You make a small little hole in the ceiling, you plug it into that access point, and there you go. Network connectivity has been established. But what that device also needs is power, electricity. Now, how are you going to give it to it if there's no electricity sockets in the roof? Where are you going to get it from? You're going to get it through your network cable. That is where PoE comes into play. It's power over Ethernet. So yes, you use your network cable for data, but you can also use that exact same cable to send power at the same time as your data. So what's going to happen is you're going to plug that cable into a little PoE device in the wall. And in that PoE device, it normally has two ports. One cable, you plug a cable end into the one end and another cable into the other end. It allows you to inject power into a network cable is what we're doing. And if it's just a small little household device, you can go use a little small little device like the one you guys see in the picture there. But in a company environment, we don't actually use those small devices. We use what we call PoE switches. It looks exactly like a normal switch. It works exactly like a normal switch, except that is a PoE switch. So any cable you plug into that switch automatically has power injected into it as well. So that's what we're going to use in a company. So any company that has got access points, which is pretty much any company these days, I can almost guarantee you that that access point is plugged into not just a switch, but a PoE switch. So that cable is plugged into a PoE switch. This is also quite useful with telephones. Nowadays, phones that's used in companies are not the old conventional phones. It's telephones that use network cables, which means they use VoIP. They use the internet to make phone calls. They don't use the old conventional telephone system. Now, those telephones, when you go and buy them, those little VoIP handsets, you'll find that the majority of them have a network port, which you're definitely obviously going to be using, considering it's a VoIP phone. And it also generally has a little power adapter jack. And it actually comes, those phones, when you buy them in the box, it actually comes with a little adapter, kind of looks like a phone charger, that you can plug into a power outlet. So if it's a very small office, home office environment, where there's like 10 or 20 people, you might want to go and plug it into a power jack. The downside is it doesn't look very appealing because you've got extra wires now, but it gets the job done. Now, in a formal company settlement, you're probably going to want to make it look very neat and very professional. So you want to reduce the cables. So instead of using that power cable to provide power to that phone, you're going to use power over Ethernet. So as soon as that person plugs that network cable into that phone, it's automatically going to turn on. Most of these phones these days have an LCD screen. So as soon as you plug the network cable in, you're going to immediately notice the screen turns on. That is also power over Ethernet. Alright guys, so finally we are starting to move away from cables and hardware associated with cables into the category of wireless frequencies and channels. Now, as I've said earlier in this module, usually wireless is 802.11 something. So 802 is networks, but the .11 at the end tells you we're working with wireless. So with regards to wireless, the kinds of signals you get is 802.11a, B, G, N, and AC. Now, A and G is for the most part pretty much identical. They're identical in range, they're identical in speed, in pretty much all aspects, A and G are identical. The only real difference between A and G is their frequency, which they run at. You can see there, A runs at a frequency of 5 gigahertz, and G runs at a frequency of 2.4 gigahertz. B, which is also 2.4 gigahertz, that is actually Bluetooth. So it's not as used as widely as it used to be. In the old days, we used to send each other, music and pictures and stuff, to between phones using Bluetooth. God, that was, a long time ago, but very, very freakishly slow. You can still do that on phones nowadays, but nowadays people don't do that. They'll probably go and use WhatsApp or some sort of other communication, which is a lot quicker and a lot more easier. So it doesn't mean Bluetooth is not used. We still use Bluetooth, B. We would use that, to connect your phone to your car's audio system to play music, to do hands-free calls. You can use your phone to connect it to maybe an audio system in your house that plays, on the audio system. You get these boom boxes or speakers you can connect your phones to these days. You get these wireless headsets you can connect to that allows you to play, with Bluetooth. So there's a lot of functions you can use Bluetooth for. That's still pretty cool. Now, as for G and A, what the heck is that? G is probably, in my opinion, one of the most widely used frequencies. That is what the average router slash router, depending on which country you're in. Some countries pronounce it as router. Some countries pronounce it as router. So that's what the average router or router will use, and your average access point will use, is G. So when you're at the office or at your house and you're connecting to that hotspot or that Wi-Fi, you are usually connecting to G. There are cases when you might be connecting to A, you just might not know it, but generally speaking, it is G. We only use A when there's a conflict normally of G. So there's some sort of device or something in a network that's causing interference, because there's a lot of devices out there that actually, believe it or not, run at the same frequency as your wireless frequencies, being 2.4. So those devices, and this is actually covered later in the course, is things like cordless phones, not cell phones, cordless phones, and things like a microwave oven that's got nothing to do with IT, but it actually runs at 2.4 gigahertz. And that's, the list goes on. So there's other devices that runs at that frequency. So if you've got a microwave oven near your hotspot, it's going to cause interference, and you might have to switch to A instead of G, since they're exactly the same. What the cheese do we use N for? N is long range communication. That is how you wirelessly communicate between two different buildings. So if you've got two buildings and you need to connect them to one another, let's say they are a few hundred meters apart. How would you connect those buildings to one another? Or they could even be a few kilometers apart, or miles, depending on which country you're in. How do you wirelessly connect those buildings to one another? I'm not going to use a cable because that's just not feasible. It's insane, it's expensive. So we're going to do it wirelessly. So on the roof, you're going to put a dish of sorts on both buildings. It needs to have line of sight. This can run on either 2.4 or 5 gigahertz, and there's not an exact speed. It depends on how many channels you've got. Some manuals originally said it's 150 megabytes, some said it's 300, some said it's 450, some said it's 600. Here they say it's 288. At the end of the day, it depends on how many channels you've got. You can think of a channel as a lane on your highway slash freeway. If I have one lane, on that road, it can handle an X amount of cars per minute. I'm going to make up a number. Let's say it can handle 150 cars per minute. And if I've got two lanes on that highway or freeway, I can handle 300 cars per minute. 3 lanes, 450 cars per minute. 4 lanes, 600 cars per minute. So I think you guys get the picture. So the more lanes you've got, the more cars you can handle on that highway. So the more channels you've got, the more data you can transfer. So at the end of the day, it depends on how many channels you've got. That's going to determine your speed. It's used for long range. It's a very high speed, long range, line of sight wireless communication. AC is pretty much the same thing, except it's a lot faster, and it only runs in 5 gigahertz, as you can see there. So at the time of writing this, AC was running at about 1.7 gigabits per second. It's probably a lot quicker now. You never know. And if you look at there at A and G, they say it's 54 megabytes per second. That's what you need to know for the exam, and that's what they will ask you in the exam. But realistically, in real life, it no longer runs at those speeds. It's actually a lot, way, way, way faster than that nowadays. That's dial-up, people. That doesn't run a dial-up anymore. Bluetooth absolutely doesn't run at 11 anymore, but that's the number you need to know for the exam. The exam is based on these numbers that I have in front of you guys right now. So for the exam, you need to know all 5 of those frequencies. You need to know those speeds that I've got there for you guys. You need to know those frequencies there. You need to know this off by heart. Now, you're not allowed to obviously go take anything into the exam. That's obviously illegal. You're going to fail your exam immediately. So you're going to have to memorize this. This is stuff you're going to have to know off by heart. And even after the exam, this is going to, help you a lot if you know this for life. So it's not something you can go and memorize for the exam and then after the exam forget. You're going to still need to know this after the exam. So I would say print this out or write it down on a piece of paper. And like I've made the joke before, I would say go put it on a piece of paper and put it somewhere where you can see it every day. Put it behind your toilet door. So every time you go to the toilet, you can see this. I'm not even joking right now. I'm dead serious. You need to know this off by heart for the exam. Alright guys, let's talk internet connections. Now, as you know, just about every Joe nowadays, and pretty much all companies nowadays, has internet access, and well, for the most part, needs internet access. They depend on it to be able to do whatever it is they need to go and do. Their business, their, whatever it might be. It's not like 20, 30 years ago, in time where there was internet, but we didn't exactly rely on it as much. Nowadays, if you or your business does not have an internet access, it's a bit of a pickle of a situation, not something you want to be in. Now, this internet connection, whether it be at your house, whether it be at your business, is created by telecommunications companies. Could be cell phone companies, could just be internet companies that provide dedicated internet access. So in a nutshell, telecommunications companies, or in some cases, maybe even academic institutions. Now, as for internet connections, let's talk about the service providers that actually provide you with this internet connection. These service providers, which we refer to normally as an ISP, Internet Service Provider, they could be pretty much just about anyone nowadays. You can walk down the street and you'll probably be able to find yourself an ISP. They are the people that give you internet access for a monthly fee in most cases, or a fixed fee. You can go and buy yourself data in some cases, and once the data is up, it's up. You're going to have to go and buy more. Or in most cases, based on my experience, it's a monthly fee you pay and you're going to get uncapped internet or, well, a limited data amount for that month. If it's a limited data amount, which we refer to as a capped connection, once the amount is up, you're going to have to go and buy extra for the rest of the remaining month. And the extra amount normally costs you way more extra. Now, network connections to ISPs, point of presence, POP, that's going to be part of this. The types of connections you get, and it's not limited to this, is going to be things like dial-up, broadband, wireless connections. I mean, the list goes on. I mean, you would see that not even fiber is mentioned there. Most use PSTN, so the ISPs in most cases will normally go and use what we call PSTN, or AKA POTS, POTS. In other words, plain old telephone system. That's the kind of ISP that makes use of your old-fashioned conventional telephone line. That one would normally plug into your normal landline. Most of you guys tend to don't even have a landline in your house anymore. You might have had one 5 years, 10 years, 15 years ago, but you probably don't have one anymore. That old telephone line is what a lot of these internet service providers made use of, especially if you go look at something like a dial-up connection. Now, with most of you guys not having that, you cannot go and get yourself a dial-up connection. Not the biggest deal, it's not such a big deal because, quite frankly, trust me, you do not want a dial-up connection. It is such old technology and it's so extremely small and I would say slow, it's not something you want to have, quite frankly. So ISPs generally also allocate you IP addresses. Something you need to be aware of, even though they do normally allocate you IP addresses, it's your public IP address that they allocate you, not a private one. So with regards to IP addresses, there's a lot we can say there, and I'm going to basically skim the surface with that. You get what we call fixed IP addresses, which is also known as static, and you also get what we call dynamic IP addresses, both of which are seen as a private IP address inside your house or inside your company's building. And as soon as you go out onto the internet, whether it be dynamic or static that you've got inside, doesn't matter. As soon as you go out to the internet through your router or your router, you normally have what we call a public IP address. So as long as you are within your building, your house or your office building, it's a private IP address, which could be either fixed or dynamic. And as soon as you go out to the outside world through your router, it could be at your office or at your house, you have what we call a public IP address. So your ISP allocates you that public IP address. They register your domains in some cases. This is not set in stone. The IP address is kind of a guarantee in most cases, but the registering your domains is a different story. Hosting your email is also completely optional in most cases. Where in the beginning, maybe 10 years ago, that used to be quite common, but nowadays hosting your email with your ISP is very unlikely. They could potentially host websites for you if that's what you would like. Not all ISPs, have the availability to go and host your email, and not all of them have the function to go and host your websites. So that's an option. You can go and take that. That is provided that your ISP actually has that as an extra. Not all ISPs actually provide that. Enterprise ISPs offer high bandwidth through fiber optic cable. So that might have been the case when they made this course, but nowadays you don't need to have that. I mean, you can get fiber pretty much just about anywhere nowadays. If you stay in a generally large kind of city in a country, let's call it a metropolitan area, you're pretty much guaranteed to be able to have access to fiber. The fiber is normally outside your office building or outside your house, and it's normally terminated, at a wall outside your house. It could be at a pole of some kind, it could be against a wall, it's like a little box. So they'll either go and trench the street, which means they dig up the ground and they bury the fiber cable and then they bring it, against to like a little box outside your yard. Or in some countries, they might even, go and put it up with little poles. It looks like telephone poles, in some cases. It depends on which one is working out cheaper. Whichever is cheaper, that's the method they're going to go and use in most cases. So the point is, in a metropolitan area, you're probably going to have access to fiber. It is just your responsibility now to get a company out to come and put the fiber in from the street box to your house. That's called splicing. So you need to have it spliced from the street box, or if you're staying in a complex of some kind, it's probably going to be inside the complex. From wherever that box is, you need to go and have it spliced from that box to your house. Once it's in your house or your office building, there's going to be like a small little white box, which we normally refer to as an ONT. It's where the fiber is going to terminate. And from that little box, you're going to get a normal old-fashioned network cable, which is going to plug into your router in your house, which looks pretty much like a normal router. And it works like a normal router. Now, as for internet connection types, let's take a look at some of them. The first one is fiber optic internet access. Now, for the most part, this is probably the one you guys want. And this is probably the one that most of you guys have at this point in time. If you do not have fiber yet, it's probably something you're going to look at getting, because it's very fast, very stable, very reliable, and that, quite frankly, is the future at this point in time. Gives you higher bandwidth over very, very long distance. It's obviously way better than copper for many reasons. In some countries, they keep stealing the copper cables, like in my country. So fiber, very expensive to go and implement, very difficult to go and implement, but once it's there, it's worthless. It's worthless for them to go and steal it, unlike copper, which is obviously has value when they go and steal the cables. So fiber is going to be a lot faster, way more reliable, and they're not going to go and steal it. There's many pros to fiber. Obviously, it has replaced copper as a core of telecommunications networks. So nowadays, you're going to find that your average telecommunications company are not going to go and put in copper wires. They're only going to make use of fiber. That is the way forward. It is being extended to individual homes and businesses. This depends on which country you're staying in. And if it is in your country, it might very well depend on where in your country you're staying in. In most countries, it's only in the more bigger cities, I would say, the metropolitan areas. Might not be available yet in the smaller towns or suburbs. It might only be in the metropolitan areas. If you go to your smaller villages, smaller towns, or small general areas, you might only have access to your old conventional DSL, ADSL. I wouldn't say dial-up, but that's kind of extinct at this point in time. But that's pretty much what you're going to have access to. Let's take a look at another one. Here we have dial-up. Now you might be wondering, why am I showing you guys dial-up? And why am I explaining dial-up if I just said it's pretty much extinct? It is because this is asked in the exam. It is covered in the exam. It is something you need to know for the exam. And once you pass the exam, you can pretty much go and forget whatever I've explained here. So whatever I'm about to explain to you, as soon as you've passed these exams, you can pretty much go and delete it in your head because you're not going to use it going forward. Because we don't use dial-up anymore. It's pretty much extinct. So dial-up connections make use of your old telephone line, which you probably don't have anymore, your old POTS line, POTS. So that is something you need to remember for the exam. Dial-up makes use of your old telephone lines, the ones that's got an RJ11. The old RJ11, that's the one that looks like a network cables connector, but it's a little bit smaller. So it makes use of an RJ11. It makes use of a POTS line, the old conventional telephone system. And with that old conventional telephone system, you plug that into your modem, and that's the exact same line you would normally use back in the day to make your phone calls. The downside was you could not make a phone call at the same time as when you were using the internet. So you had to make a choice. Either you were on the internet or you would make a phone call. If someone calls you while you're on the internet, it would quite often drop your internet connection. You would have to start the whole connection over with. And depending on what your ISP setup was, you're probably going to go and pay again. It's kind of like making a phone call. So generally, you would pay for that phone call or that dial-up connection. You would pay for the connection. Some companies, might be lucky to have a fixed fee. So it's going to charge you a certain amount up until the first 5 minutes. And then beyond that, it's going to be a fixed fee. But if someone calls you, it drops the connection. You start the whole fee all over again. You get charged again. Or if you need to call someone, you're going to have to drop your internet connection. You can only do one at a time. So the most important part here is it uses the old telephone system line, which is analog. The old telephone lines were analog, and you cannot make a phone call and be on the internet at the same time. It's either or. So what that old telephone line does is you plug it into your modem, and remember that old telephone line is analog. That's very important for the exam. It's analog. It's old technology. Your modem takes that signal, which comes from the telephone line, converts it to digital. Converts it to digital, which is something that your computer, your laptop, or whatever you're going to be using the internet on, understands. Your computer doesn't understand analog. It only understands digital. But the telephone line is analog. So that's where the modem comes in. It's a medium in the middle. You can call it a translator even, if you will. It takes the old analog signal from the telephone line, converts it to digital, something your computer can understand, and there you go. Your computer has internet access over the old conventional telephone line. And when your computer wants to send information, it sends it to the modem, obviously in digital form. Modem converts it back to analog, and it sends it over the telephone line. That's all you need to remember. So yeah, phone chargers apply. Line cannot be used for voice at the same time. We've mentioned that already. Modems at each end convert digital to analog and analog to digital. So that may very well be a question in the exam. They're going to ask you which one of the following devices can convert an analog signal to digital or digital to analog, or both for that matter. But the device in question is obviously going to be a modem. A modem converts an analog signal to digital and vice versa. Remember that for the exam. That's all you need to know. That's the only reason why we're discussing dial-up. Quite frankly, in real life, you're not going to be using a dial-up connection because it's too slow, and it's for the most part extinct. I mean, you don't even have telephone lines nowadays anymore. So even if you have a modem, where are you going to get a telephone line? And let's say you do have a telephone line. Your ISP is probably not going to be able to provide you with dial-up anymore because they probably discontinued that service. So let's take a look at the next one up, which is fixed wireless internet access. So when we say fixed wireless access, this means you are going to get wireless access, obviously, wireless internet, but it means you also cannot move around. So unfixed wireless internet would obviously be something like a dongle, which you can plug into your laptop, or something you can grab, put it under the arm, and you can take it with you. You can go anywhere else for that matter. Maybe take it to the office. Fixed normally is a matter of you've got a dish on your house's roof, your office's roof, or it could be some sort of dish or receiver in your yard, possibly in your garden. From that dish, there's a wire, and it's normally a network cable that goes in all the way into your house or your office building, into your router or router, depending on which country you're in. Goes into your device in your house, being your router or your router. And from there, your router or your router will provide you in your house or you in your office building with internet access. It's a fixed internet connection. Unfortunately, you cannot just go and grab the equipment and take it somewhere else because that dish has been mounted. That dish needs line of sight. In most cases, it uses the wireless frequency called 802.11n. And if you guys remember the wireless frequency we discussed earlier in this module, you can actually go and use that timestamp if you missed that. Look for that down in the description down below. So we're using the 802.11n. It's a long-range wireless frequency. It can work both on 2.4 gigahertz as well as 5 gigahertz. And it's got various speeds, as you guys might remember. It depends on the amount of channels you're using. So the channel will depend on how fast it is. But even if you have only one channel, it's a very, very fast, long-range wireless communication, which unfortunately needs line of sight. So if you're going to be hooking this dish up at your office building or your house, you're probably going to be pointing it towards a very tall building or a very tall mountain somewhere where they have some sort of, transmitter or repeater, that's most likely going to be rebroadcasting their wireless signal to you in your house. And they're going to sell it to you, obviously, for a monthly fee. That is one kind of wireless connection you can go make use of. Another kind, which is quite expensive and quite frankly not available everywhere, is satellite internet. Very expensive, it's not available everywhere, and it's very heavily influenced by weather. So if it's a cloudy day, your internet's either going to be off or very non-responsive, quite frankly. So the one that says line of sight is probably the one you're going to end up going. And that is actually very common. In countries where you're staying, let's say, just outside of town or just outside of the city, where they don't have, fiber lines, and they probably won't have anytime soon because they can't justify the costs, putting a fiber line outside for just one or two guys. So there, you don't have fiber, you don't have ADSL, you've got nothing. How are you going to have internet access besides making use of mobile networks, which might actually be very expensive? Another way to go about it is obviously go make use of this line of sight fixed wireless in providers. They generally are a lot slower than your fixed lines. So if it's an actual wired internet connection, they're way more stable, way more reliable, and just a lot more faster. The wireless ones which are fixed, they're not that bad, but they're not as stable. I'm not going to say they're unstable, but they're not nearly as stable as a fixed internet connection, or a cabled internet connection, I should say, not nearly as stable and not nearly as fast. So it's not something that you want to go and get unless you have no choice in the matter. All right, next up, Internet Protocol and IP address. Now, even though you guys might never have configured an IP address, you might not know where to go and do it or how to go and do it, I think we can all agree that you probably have heard of the word IP address at the very least. So an IP address is something that all devices use to communicate with one another. This is not just limited to desktops and laptops. It actually extends to phones, tablets, printers, scanners, pretty much any device that's connected to a network, via network or via wireless. Doesn't matter, they all use an IP address. This allows them to find one another and allows them to send data to one another. So if I, for example, want to invite you to my house right now to come over for a beer, how are you going to know how to get to my house? You're probably going to ask me for my country, for what province or state I stay in, what city or town I stay in, maybe a suburb, street address, number, street name, street number, that kind of thing. And eventually, you're going to end up at my house. An IP address works not exactly like that, but it's pretty damn close to that. It allows one machine to find another machine over the internet or over your internal network. So I think to keep things simple, let's just say over your internal network. Now, something you guys should be aware of, we're not going to go into too much depth on this right now because this is still just A+, but I will cover it for you guys in more depth later on in the bonus video for this specific course, being video 20. As you guys know, the first video is just a 4-minute intro. Then we have the 18 module videos. And then the last video, I have no idea how long that last video is going to be because it's not an official module video. But the last video of this series is going to be a bonus exam tips video and where I'm also going to cover all kinds of bonus topics for you guys. As things stand, this video is already getting too long. I apologize for that, but that effectively is the length of this module. It's a very, very long module. So yeah, computers understand what we call ones and zeros. We humans can't really understand that. We can go and work it out, on a piece of paper. But at the end of the day, what your computer sees is ones and zeros, binary. One generally means on, zero generally means off. Now an IP address, as you guys can see there way at the bottom, there's a 4-digit IP address, 4 octets, 198.41.16.9. Those are 4 octets. Each octet consists of 8 bits. In other words, 8 ones and zeros. And if you add all 4 of those octets together, what does that give you? 32 bits. There is a question that sometimes gets asked in the exam, either directly or indirectly. You need to know that an IP address consists of 32 bits. At least an IP version 4 address consists of 32 bits. Now you also get what we call an IP version 6 address, not something you guys need to be concerned with at this point in time. Looks very much like a MAC address, and it's a nightmare to go and configure those. And those use 128 bits. For fun facts, just in case they ask it in the exam, they might not. It's 128 bits, 4 times more than your IP version 4. Now, even though we have many IP addresses, we're currently running out of IP addresses in the world. So there's been certain measures put in place to allow us to connect devices to one another, even though we're actually running out of IP addresses. One of those measures that's been put in place is IP version 6, which gives us way more extra IP addresses. It's not the only solution that's been put in place. So all of that was stuff that we're going to get into more later on in other videos in this specific course. So moving on to something else that's got to do with networking is subnet masks. So anyone that's ever configured an IP address on a computer would probably know or have seen this. As soon as you type in an IP address into your computer, the block directly below that is going to say subnet mask. And in most cases, when you click on that block, it's automatically going to go and complete it. And 10 to 1, it's probably going to be 22255.0, which is considered a Class C network. Class B is when you only see 2 55s in the front, which is that middle one on the left. So it's 255, 255, and the last 2 numbers could either be 2 zeros or anything else for that matter. It does not necessarily have to be 2 zeros at the back. As long as it's anything else other than 255, it means it's a Class B. That distinguishes the size of your network. More on that in just a moment. But if you only see one in the front, which is just 1255, that's a Class A network. That is the biggest kind of network we have. If you look at the first one we discussed, which was Class C, that's the most common one. Class C has roughly about 256 IP addresses, of which you can use 254. The first IP address and the last IP address can never be used in a network. So it's only a mere 256. Well, 254 if you want to be that precise. So 254 IP addresses, that's not enough if it's a very large enterprise. A small household, a very small office building, maybe. But anything bigger than, or any place where you've got more than 250 devices, that's going to be a problem. It does not even have to be more than 250 people, just more than 250 devices. Because if you have 120 people, you might already be over that quota. Because the average Joe nowadays has 2 or 3 devices. And that, as we know, each device needs an IP address. So it's a real problem. If you look at the second one there being Class B, that gives you give or take 16,000 odd IP addresses. And the last one gives you give or take about 16 million IP addresses odd. Now that might sound like a lot to you guys, but if you go look at how many people there are in the world, there's about plus minus 8 billion people in the world. And the average Joe has about 2 or 3 devices. So that's about 16 to 24 potential billion devices that needs an IP address to go onto the internet. You cannot go onto the internet and browse if you don't have an IP. And even if we use the biggest one here being Class A, we only have a mere 16 million. And we need about up to 24 billion. So we've got a bit of a shortage, which is obviously where other measures comes into play, like IP version 6. It's not the only thing. You also get something called a private IP address and a public IP address. Something we did mention just briefly a while ago. So we're still getting to that. Before we get to that though, let's discuss the difference between static and dynamic IP addresses, both of which are currently private. So anything within your household or within your office building is seen as a private IP address, something that you or your fellow colleagues or someone in the building has got control over. Now static, which is also sometimes called fixed, is an IP address that you are going to go and configure manually on a machine, a server, a desktop, a laptop or something. You configure it manually, and when you configure it manually, it normally stays like that until someone goes and changes it one day. So unless someone goes and changes it, it's going to stay on that IP permanently. Dynamic is when that machine currently does not have an IP address, and as soon as that laptop, desktop, tablet, or whatever the device in question is, as soon as it connects to the network, one way or another, it's going to go and request an IP address from the DHCP. So if it's a Wi-Fi that it connects to, as soon as it connects to the Wi-Fi, it asks for one. If it's a cable, as soon as you plug the cable in, it asks for one. So let's imagine it's a desktop PC. As soon as you turn it on, or as soon as you plug it into the network, it's going to do what we call an ARP request. Basically just says, hello, is there anyone out there? It's obviously looking for a DHCP. Hello, is there a DHCP? And if there is, which there normally is, the DHCP is going to say, yes, I'm here. How can I help you? And your machine is going to say, you know what, dude, I need an IP address. And the DHCP is going to say, well, sure, I'll hook you up. And it's going to go and check if it has one available. The DHCP has a scope. The scope is basically just a range of IP addresses that's available. You can think of it as a pool. It has maybe 100 IP addresses that's available. And if there's already 100 devices that's requested an IP address, then there might very well not be an IP address left. Think of this as going to a mall or a shopping center where there's parking lot. Obviously, there's only a certain amount of parking. So sometimes you're going to find a parking easy. Sometimes you're going to drive around a bit before you find one. Sometimes you're going to drive up and down, and you will not find one. And the only thing you can do now is wait for someone to come out, basically stalk them, if you will. And when you eventually see them go to their car and they remove their car and they skedaddle, you can go and take their parking. DHCP works very much the same. So your PC is going to ask for an IP address, kind of like you driving around that parking lot looking for a parking. And if there is a parking available, you're going to take it. Just like if there's an IP address available, you're going to get it. Now, sometimes you might go to that parking lot. Maybe it's the end of the month. It's maybe, Christmas Eve, it's New Year's Eve or something, some sort of holiday. And all the parkings are full because everybody's shopping. Now what? So you're going to have to wait until someone vacates their parking and then you can get it. Same applies to that IP address. So if there's none available, your device is just going to keep saying requesting, requesting, and nothing's going to happen. If you try and open your browser right after connecting to the Wi-Fi, nothing's going to happen. Or if you plug the cable in, you try and open your browser, nothing's going to happen. It's because your PC doesn't have an IP. So you're just going to have to leave it. And then one day, when someone turns off one of their devices that's on the network, or when they disconnect, in other words, just disconnect from the Wi-Fi, plug the network cable out, that machine that had an IP address releases that IP address back into the pool. And if that IP address gets released, it's the same as that person in the parking lot taking their car and vacating that parking, which means you can now occupy that parking, which means now you can get that IP address. So that's dynamic IP addressing, people, in a nutshell. More on that, there's actually a whole videos that I've got on that. That's more in the server section. I will have more dedicated videos on that in the Network Plus series, but if you are curious about dynamicing, I do have a series on this channel. It's called Server 2019. The code for it is WS-011. So there's a whole playlist on that, and in that playlist, go look specifically for DHCP. If you're curious on how IP addressing works, go check the DHCP section. There's a whole video too specifically covering just IP addressing, DHCP, and all of that, and it explains in detail how that actually works, in case you guys are curious about that. So moving on, here we have finally public and private IP addresses. Now, as I've said briefly before in this specific module, a private IP address is something you have inside the building, like that DHCP IP address or that static IP address. As long as you are within your household, or as long as you are within your office building, you have what we call a private IP address. It's only visible for you and the people within that building. Public as an IP address you will get as soon as you go through your router or your router. So if you have a router or a router in your house, as soon as you go through that router onto the internet, let's say you go to a web page of some kind, you, my friend, have a public IP address. Same applies to the office. As soon as you go through that router or router, you've got a public IP. So you might find if you go online to a website of some kind, let's say it's an illegal website, one of those naughty sites, they will generally show you what your public IP is. They'll tell you, you've got an IP that's blah, blah, blah. Please go and use a VPN, is what they might tell you. They're not wrong about the VPN. And quite frankly, they're normally not wrong about your IP as well. That IP they show you is really your IP address. It's your public IP address, not your private one. So that public IP address is going to trace you towards, I wouldn't say it's going to trace you exactly to your household, but if we want, we can trace you to your ISP. So I can trace you to your country, your city, in some cases to your ISP. Some people really know what they're doing. They can even trace you to your household, to the nearest router in some cases. So it is important to go and hide your IP address. More on that if you guys want to know about that. So if you want to know how to go and protect yourself, feel free to drop a comment down below and I'll gladly answer your question on how you can go and protect it. Just explain to your situation to me. Are you at home? Are you at the office? What do you intend? Why do you want to hide yourself? Are you going onto naughty websites? And then I can help you more accurately if I know what the situation is. You don't have to disclose any private information, obviously. You don't have to do that. So yeah. That's what a private IP address and a public IP address situation is. There's pros and cons to this, obviously. I mean, if I go to a website, let's say I'm in the office building and I go to a website and I am not on that website, what are they going to do? They're probably going to ban me, or something like that, suspend my account. How do they do that? One of the ways they do that is by blocking your public IP address. Now, what a lot of people don't know is when you go onto the internet, you're actually sharing the same public IP along with a lot of other people. Your ISP normally gives that public IP to pretty much most of their clients. So if in your building, let's say your office building, each and every person has their own unique little IP address. But as soon as you people go through that router or that router, you all share the same public IP. So you might find in your office building there's 100 employees. Each of them has their own little private IP address. But on the internet, all 100 of them have the same public IP. They all get shoved into the same pipe, so to speak. So if one of you guys are naughty, let's say on Facebook, and Facebook decides to ban your IP address, now the next guy goes onto Facebook, completely innocent, none the wiser, and he or she tries to log on and says, nope, you've been banned. And they're going to scratch their head and wonder, what the cheese is going on now? They haven't done anything. Why are they banned? It's because Facebook sees the same public IP and it thinks it's the same person, even though it's not. because you're sharing the same public IP. So that's a con, obviously. A pro would be if you need to go and allow your organization access to certain something. Let's say there's a SQL database in the cloud, and you want to allow your employees within the office to gain access to that SQL database. Now, the way you're going to do that, one of the ways, is via the IP address. Can you imagine if you had 100 people and you had to go and allow them one by one by one? No, I think not. That's going to kill you. So lucky for you, they all share the same public IP within that building. And with that said, you only need to add that one public IP and you're automatically gonna go allow everybody within the building. You'll see at the bottom, we also make mention there of a router using NAT. So NAT is Network Address Translation. In a nutshell, that basically just converts your public IP to private and private to public. So when you are inside your network and you go through the router does something called NAT, converts that private IP of yours to a public IP, and when traffic comes back in, it just does vice versa. You can also go make use of proxy servers. Not something we're really going to go into depth right now, but one of the things it does is it's basically a server with a set of rules. Most companies and organizations these days have such servers. Think of it as a bouncer. So if you have a proxy server within your organization, it's basically going to have a bunch of commandments that says thou shall not go onto Facebook. Thou shall not go onto YouTube. That's an example. So when someone in your company tries to go to Facebook, that traffic has to go through your proxy server. And when it goes through the proxy server is basically going to go and inspect where you want to go to. It's going to say, whoa, 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 hold up, buddy. Where are you going to? And if it sees you're trying to go to Facebook, it's going to say, whoa, buddy, sorry, no, that's on the no-no list. Go back. You're not allowed to. If you're trying to go to YouTube, same story. But if you're trying to go to a website that's not on the naughty list, it's going to allow you through. So the proxy server in a nutshell is a list of sites that you're allowed to go and visit and not allowed to go and visit. It's not the only thing it does, but it's the best example I can give you guys in such a short amount of time, obviously. Alright guys, and then we have our last topic for this module, I promise. I know it's been a long module, but I have no control over that. I did promise I was going to do each module in one video, and I'm going to try and stick to that. So this topic is well-known ports. You probably already know what a port is. It's a port number, so there's about 65,000 odd port numbers. Can't remember the exact number. I think it's about 65,536 or 53. I can't remember the exact number. So let's just say 65,000 port numbers. That's a lot. Think of each of these port numbers as a window or a door into your house or your office building. And for you to keep an eye on each and every one of those windows to make sure they're closed if you're not using them is a nightmare, obviously. So what happens is, in most cases, most ports are closed by default for your safety and your environment safety. Now, there are certain ports which are actually open by default. These are known as well-known ports. They're normally associated to certain things that we use every day. Every Joe uses these things. And I'm going to give you guys a list here of some of those well-known ports. So here are some of them. That is not all of them. I quite frankly ran out of space there. I might have missed a few, but that's besides the point. You can actually go find them in your manual. You can run a search online on Google or wherever, and you can just go and say well-known port numbers. It's going to give you a full extensive list of all the well-known port numbers. Now you need to familiarize yourself with some of these port numbers. So I would say go and get a list on Google of all the well-known port numbers, not just these ones I've mentioned here. Get that list and know what each of them are for. So for your A+ exam, you need to know all the well-known port numbers, not all 65,000 port numbers, just all the well-known ones. That's going to be about 20 or 30 port numbers. So familiarize yourself. You don't need to know maybe off by heart, but familiarize yourself with those port numbers, what they're used for, and I suppose that's pretty much it. I would say just what they are and what they're used for. So for example, I'm going to go and give you guys an indication of what these are used for. Port 20 and 21, for example, is FTP, File Transfer Protocol. 22 is SSH, Secure Shell. 23 is Telnet. So Telnet is a form of remote connectivity where you, via command-based, basically remote connect to something like a router. SSH, pretty much the same thing, except that's just encrypted. SMTP is sending email. That's sending email, not receiving, specifically sending email, but that's the old one, which most of us don't use anymore. 53 is DNS. 80 is HTTP, Hypertext Transfer Protocol, so that's normal web browsing. 8080 is also web browsing. I suppose you can call that the backdoor, so to speak. Not exactly. 110 is POP3, that is receiving email. Pretty much the exact opposite of port 25. 443 is also web browsing, except that is encrypted web browsing. And then we have 3389, which is remote desktop protocol. That's normal remote desktop. So go and make a list of all the well-known port numbers, what they are and what each of those things are. For example, now you might know that port 80 is HTTP, but you might not know what HTTP is. That's web browsing. So know what it is, in other words, HTTP, and know what HTTP is. Just more or less. What is HTTP? It's web browsing. Normal web browsing. Of course, in the exam, you might very well get a question that says, you need to allow user 1 to browse the internet. What port would you go and allow? And they're going to give you a list of ports, and you need to know which port is which. In this case, it's going to be port 80. The ones I've normally seen them asking exams normally port 20 and 21, but quite frankly, it can actually be any port. The principle is what's important here. So don't go and memorize it. You need to understand the principle here, guys. Now, I'm not sure who made this list. I don't know if it was CompTIA. I doubt it was CompTIA themselves. But this list was effectively established a very long time ago. And at that point in time, there was obviously not nearly as many services as we've got now today in today's age. Today's age, if you go look at something simple as email, most people use Office 365 email, which has its own set of ports, but they're not seen as well known. You could potentially go and use Gmail, Hotmail, Outlook, there's so many kinds of email you get, and none of those port numbers are seen as well known. But if you do need to allow those ports or block them, you can go and Google them, you'll find them, and you can just go and block them or allow them respectively. But way in the beginning, they were seen as well known. Now, Gmail is obviously something everybody uses, but it's yet not seen as well known because this was established a long time ago. So yeah, I'm just a messenger, don't shoot me. Speaking of Messenger, like I said earlier, I do know this is a very long module, and once again I apologize for that, but I did make a promise in the beginning that I was going to do each module in one video. And this happens to be a very long module. It also happens to be a very important module. There's an exceptionally large amount of content in this module that's going to get asked in the exam. So I would probably say that this is one of the most important modules for your A+ exam, at least the Core 1 exam. It is also important to know that these exams do cross-pollinate. So just because you did the Core 1 course, in other words, which is up to Module 9, that does not automatically mean you're ready to go and write the first exam, being Core 1. So yes, most of your questions are going to be coming out of Core 1, if you can go write the Core 1. And if you go write Core 2, yes, most of your questions are going to come out of Core 2, which is Module 10 all the way to Module 18. But they do cross-pollinate these exams. So it's not uncommon to write Core 1 and get questions from Core 2. And it's not uncommon to write Core 2 and to get questions from Core 1. So my advice to anyone would be to do the whole course, whether you do it through me, an institution, or when you go through the manuals yourself, doesn't matter. Do all 18 modules before you attempt your first exam. Do not do Core 1 and then go and write Core 1 and think you're ready to go and write the exam. That's going to get you to fail the exam. Unless you've got a lot of experience, you might fail the exam then. Do all the work. At the end of the day, you're going to have to go through all of it anyway. So it's not going to take you longer. You would have gone through all the work anyway. It's not like you're doing extra work. You're just delaying your first exam is all you're doing. But at the end of the day, it is not more work. It might feel like that because it's going to feel like you're writing slower now, but you're not. It's still the same amount of work. This is just to get rid of that cross-pollinating issue where you go write the first exam, you only did the first 9 modules in your book or institution or my videos or whoever's videos, and then they ask you a question about the second core, and now you've got no cooking clue what they're asking you. So watch out for that. Anyway, guys, so like I said, I apologize for the long video. And if you've enjoyed this video, if you feel like you've learned something, please give this video a like. It does help me. It does help my channel. It does help my video. It basically promotes my channel when you go and give it a like. If you're new on the channel and you would like to know when Module 9 comes out or any other module or just quite frankly want to upload something in general, please subscribe and preferably do it with the notification bell. Otherwise, it's not really going to help you. Otherwise, you're not going to know when it actually comes out. And if you need additional help on this module, on a specific topic, or just the course in general, drop your comments down below. I'll gladly get back to you. Or alternatively, you can just join me on Discord. You'll find in the description down below, along with the timestamps for this video, you can go and use those if you'd like to go and revise. There's a Discord server link. That Discord, like I've said in the beginning of this video, is not my server. It's an IT community consisting of over 2,000 people. Some of them are experts, some of them are not. but you can find help on there. Either from myself or someone in the field will definitely assist you. If you want to talk to me on that server room, I'm listed as Burning Ice Tech. You can either directly message me, directly DM me in that server, or you can just chat me there, in one of those chat rooms. Go to the A plus chat room and you'll find me there as well. I'm also listed in A plus chat room. So yeah, guys, that's effectively me. That's effectively module 8. And I'll see you on module 9, which is going to be the last module for core 1. Then we're going to be starting with module 10, which is the first module for core 2. So module 9 will be the last module for core 1, but I do encourage you to finish the whole core 2 as well before you actually attempt your first exam. So see you guys on the last module for core 1, being module 9.
If you love me, let me know. If you don't, then let me